Merhabalar.
Hello everyone, welcome to Solarex 2026. We will be talking today, I do apologize, the critical role of storage and grid integration in the 2035 renewable energy targets. Welcome to our session. Doğacan Bey will be our moderator today, and we have Aziz Kömürcü, Dr. Ömer Faruk Tunçbilek, Ramazan Kaya, and Ömer Doğan with us today. With their contribution, we'll be carrying out our session, and I would like, without further ado, to leave the floor to our moderator. Canım, thank you very much. Dear speakers, welcome. Thank you for being here today. And I would like to thank everyone for sparing the time to be with us, to listen to us today. We have some very valuable guests who are association members. The storage industry has really accelerated. We set off 5 years ago individually, and it's the start of the journey in our country as well. And concrete steps have been taken in renewable energy. We have the first power stations that have been receiving their certifications, and we see that production and exports of our country will be contributed to by this, and our efforts in our association for 2.5 years now have been continuing in this line. We, together with our very valuable members of our association, because some are in production, some are investors, some are decision makers on the state side. All together, we are coming together with a joint mind to move forward. So yet again, I would like to thank all of you for being here. And today, I want to start with questions for Aziz Bey, if that's okay with you. Yes, of course. So it's very important that on the ministry side, on the acceptance side, you're in management essentially, in the decision-making side. This is a position that requires responsibility as well as, obviously, it's very valuable for us to include energy storage systems in our country. And obviously, quality comes to the forefront here, and investors need to be prevented, and efforts have been made to prevent unsuitable storage devices from being introduced into our grid, and a specific quality level is attempted right now. So what are we experiencing with our first installations? Our local producers obviously have, manufacturers I believe, have very successful efforts, and we're going to have up to 1 gigawatt hour by the end of the year in accepted or licensed. So how would you consider the developments in this arena? The certification processes, what are our requests in that regard to ensure the quality, and what are your expectations from the industry? That's what I'd like to hear from you. Thank you very much, dear Chairman, and dear guests. I would like to say welcome to all of you, dear participants. Yes, as energy investments at the Energy Ministry, power generation processes are being managed at our ministry, the acceptance and licensing. Solar power stations, thermic, biomass, wind power, these have become normal for us in the past 15-20 years, and specific experience has also been developed in this arena. But when we consider the past 2 years, power storage facilities are on our agenda. 2024 was the introduction or the creation of the legislation for energy storage plants, and obviously the relevant colleagues in the ministry, we don't just set out, let's write something for this. We dealt with everyone involved in storage facilities, technology producers, engineers, investors. We came together. We invite them individually. We meet with them, with all stakeholders. We bring them all together. Once we come together, we carry out negotiations, meetings, discussions to come to a conclusion. So 2024 for us was the arrangement of legislation for storage facilities, and we listened to all our stakeholders in this regard, those active in Turkey, those in Europe, in China, in the Far East, all foreign companies we invited to the Energy Ministry. We listened to all individually, and as a result, legislation emerged. And from the ministry side and all associations, regulators, it has reached a certain maturity and has been published. And our facilities have, our investors who have created their capacity and received their licenses first for pre-approval for their projects. Obviously, in the pre-approval purpose, we first approve a draft project. The investors receive their capacity, their license, and they have their objective of their facility, and they present to us a project in this regard. There are certain documents and certifications that we request in this regard. And in 2025, obviously, we didn't have a very busy pre-approval process. However, when we reach 2026, I believe we currently have over 1,500 megawatt storage facility pre-approval, project pre-approvals that have been carried out. And I would say this is the first quarter, the first 3 months of the year. And when we consider it on a yearly basis, approximately 8,000 megawatts we believe this will reach, the pre-approval projects. And obviously, within 6 months, the final projects are applied for. And when it comes to the final project, everything we begin to investigate everything, analyze everything. So what do we consider? We look at the structure license, the zoning, we look at the signed technical and administrative protocols between the investor and their suppliers. We look at their environmental certifications, their engineering studies. So we essentially look at everything that is required for that project to be realized, and this is investigated and analyzed during the final project application. Yes, the legislative studies were carried out in depth with all stakeholders and were published, but that does not mean that everything is perfect. It doesn't mean that there is no deficiency in anything that we've done, that it is perfect. When do we do things best? We go into the field and we see what is missing, what is deficient. So when we actually begin working, yes, everything looks great on paper, but when we enter into the field, when we go down onto the field, we see whether what we have written in paper is applicable in the field. We can only determine that when we get to the field. So for us, the determination of whether it's applicable or not is 2026, this first 3 months. When we look at what we've done in the past 3 months, yes, in the projects and acceptance of many of these facilities, we've dealt with many problems. First, administrative subjects I'd like to talk about, and then if we have time, I'll move on. I think we have time, Chairman. First, let me deal with some administrative. We have so many stakeholders and investors here in the industry, in the supplier side, on the technology side. First of all, the construction permits. Let's say solar energy plants with storage receives construction permits for only the power plants, but what we demand in our legislation is for the storage units. So a structure permit showing the storage units. This is the first area where we suffer problems. Then we have zoning issues as well. Yes, we have a storage solar power plant, and the investor has only shown it as a solar power plant and obtained their zoning permits. However, there is a storage unit here as well, and at the end of the day, when the zoning is being carried out there, the fire regulations, for example, of the municipalities, when storage enters into the arena, many things change. Many standards enter into force, many precautions need to be taken in this regard. And in the zoning, for example, we need to have a zoning plan that shows the storage facility or unit. We've seen a lot of problems in this regard on the investor side. And let's move on to the technical side, which is these two main areas are problems that we face a lot with investors. But when it comes to the technical side, yes, of course, when we were preparing the legislation, we wrote certain standards and tests of the AC standards, like capacity test, for example. I'm sure you're aware of this. The capacity test, what we said was this: within 1 hour, whatever the power is specified in our license, that license needs that power needs to be able to output it to the system, because these capacities have been allocated with the law. So what does the law state? It says that if you're going to do a storage facility of 30 megawatts, then you need to get the capacity for your wind or solar power station. This is what the law states. So if you have a 30 megawatts of power storage unit which is going to be established, this electrical power, you need to be able to output for 1 hour to the system, because you have obtained capacity for this. This is actually a commitment, and the investor is required to fulfill this commitment. So setting off from this, in our own legislation, when our colleagues or friends go for acceptance, within 1 hour, that test power needs to be achieved. That value is required to be seen within 1 hour at acceptance. If they cannot see this, then the facility will be rejected. It will not be accepted.
In such a case, if the admittance is denied in the field, of course we have an investor and a supplier there in the working, engaged in the area, so it is not a healthy outcome for both of those sides, especially given that we live in the developmental stages of this sector. At this point, I suppose the investors prefer the cheaper uncertified products that are not standard, that are part standard, substandard. At this point, we invite the investors, especially for the preliminary projects and the project stages. And at this stage, we explain the situation to the investors. If you fail this test, your facilities will be rejected, denied, and they will not be commissioned. Therefore, the products that you choose should not be cheaper ones, generic ones. They need to be in full compliance with the international standards. Similarly, with the power test, we have a capacity test that's carried out in the field. There are ambiguities related to that capacity test. I'd like to clarify. In this test, you have a storage facility with 50 megawatt hour capacity installation. In this project, the 50 megawatt hours needs to be proven to be stored, with which we can also monitor. We need to be able to monitor all through the systems in field. Of course, from the technological point of view, you cannot have the DOD at 0 when you store. You have 5% as the figure that's being spoken there. DOs we can discharge up to 5%. So the 50 megawatt hours energy that's to be stored there, I need to be able to charge it within given time period. But at this point we have a problem. And regarding the market authorities legislation, there's a tolerance which is 10%. The 10% tolerance is also considered in these tests. So when we talk about 50 megawatts hours, we have a 50 megawatts power at hand. You need to be able to feed up to 45 kilowatt hours within 1 hour, which meets the 10% tolerance, including the internal demand as well. When we look at the internal demand, domestic demand, the losses and the demands within the company are included in the tolerance figures. So this tolerance is stipulated in consideration with the losses and the demands within the installation facility. So, as far as practical, I believe we completed 7 or 8 admittance processes, both the storage facilities and the generation facilities. In our tests, these 2 points have emerged as problematic areas. Yeah, of course, this is the nature of the market, but when you explain everything to the suppliers, to the investors, you can eliminate the problems. Another major problem that we encounter is the certification and standardization. Unfortunately, we generate. This applies to all sectors in Turkey, as far as I can tell. We can do many things in the field, in the industry, as electromechanical facilities. We produce every kind of equipment, every items. But when you look at the standardization, we have a lot of gaps. I produce a telephone, but without standardization. This is as an example I'm saying by relation, for example. In Turkey, the storage facilities, we have 4 or 5 domestic companies, and we are in contact with them. We contacted them beforehand so that we make sure that they know the fact that they need to meet standards and they need to have certain certifications. And then, as of now, after 8%, 9%, 90%, 80%, they take us seriously, and they completed a majority of the certifications that we required from them by themselves. And the important topic here is we have standards for the certifications that are also ongoing processes. So sometimes certification can be completed only within 2 years. We have our own certification process as well. Yeah, we look at in the good faith of the investor there. If they are putting the required effort, required work to have the certification, and if we see their interest in doing everything by the book, we tend to help them. At the end of the day, they are the domestic producers, domestic creators. They are the purpose of this country, and we need to ensure that they not only survive but also thrive. This is our perspective. Another important point of consideration, and we may have some suppliers here in this hall with us, so I'd like to underline this. We do not have the R&D in the production side of the things here. The R&D is carried out in China and Europe, perhaps 80% in China and 20% in Europe. And the producers, manufacturers, over 90% of them are based in China. So our investors find a partner, and they want to transfer technology to Turkey, import the technology to Turkey. So they install this plant, create a factory. They want to manufacture the same product here in Turkey. But the product that's being manufactured in China has a certification, and they qualify certain standards, which applies to the product that's being manufactured there. When you manufacture the same product here in Turkey, the product that you manufacture here in Turkey needs to have certification and needs to meet standards. We do not accept the Chinese versions of those. It's only valid in China. So that I believe we have investors and manufacturers and the suppliers here. This is important, and investors need to pay special attention to this, because in the future, when you will come to the process of commissioning and admission, perhaps you will be disappointed. So a lot of problems in the field, dear moderator. If you want me to continue, I can continue with the problems. For today, we have heard enough problems, I believe. We have satisfactorily mentioned the important items. And I'd like to thank you again on behalf of everyone in the attendance, because these informations are important. All the information that's been presented by him are important. They are strategical, especially the problems that occur during the admittance processes can also negatively impact the actual manufacturers, suppliers, generators. We need to do our best, and the solution lies within informing everyone properly in due time. So I would like to thank you for all your efforts in the sector and your positive approach. Mr. Ömer Faruk, when he started from this admittance processes, I'd like to ask a question to him. Super permits, we mentioned them before. What's the situation right now? What are the bottlenecks in the permit processes? Yeah, there are, because when we talk about licensing, a lot of companies have been experiencing problems. Can you provide some information about it? Hello, everyone. I am the director of the Galata Base, and I'm vice chairman in the association too. Before this session, when we talk with Doha, generally speaking, I can say that the permit processes still continue to suffer from cancer, certain cancers. From the storage side, I am on the investment side. We have a storage project for 410 megawatts. We are trying to get a license and for the project and start the investment. More than 3 years old, within the EMRA, they held tenders for solar power plants and storage facilities for them. 19 megawatts for solar renewable energy, and they distributed preliminary licenses. Pre-license. That does mean, yeah, we are starting this process. But transformation of these pre-licenses to the licenses and from licensing to the construction side, we call entirety of this process as permit process. In the sector, we have the perception that perhaps the ministry is aware of this. Maybe Ömer Faruk is aware himself. Azizbey needs to have the license because it has been 3 years, but the processes take up to 3.5 or 4 years. So the ministry saw the fact that the processes continue for a long time, which is also parallel in Europe too. Sometimes in certain European countries, it can take up to 5, 6, even 8 years, starting from the preliminary license to the generation. I mean, the ministry solved this problem, and there is a vice president who also especially puts certain efforts in this regard. And this project that was called super permits in the sector launched in the previous period. In 8-9 months ago, a law was enacted for simplification and acceleration of these processes, because Turkey needs this renewable energy and storage capacity significantly. There is no new thermal power plant investments in Turkey. We will have a new natural gas power plant. Of course, it's not sufficient, and since we have not commissioned the nuclear so far, we need storage. Ministry also says the same. So the law was enacted for the super permits. What does it say? For the forestry areas that will be used for such investment, we used to have two different permits. Now it's reduced to one single one. Before the environment AEA, we cannot start the zoning and other permits processes before completion of the AEA processes, environmental impact assessment processes. Yeah, it was solved too. And local municipalities have different implications, practices, especially financial side. In 2 different municipalities, a map that was that charged me over 15 million Turkish liras for a single map. Another municipality charged me only 242,000 Turkish liras. So ministry seeing these differences extended a helping hand. So we have the process continued. When we were expecting up to 1 gigawatt of the storage for the year 2025, but so far we have active storage facilities up to 220 megawatts. when we can foresee future problems in this year too, because we do not have the sufficient legislation and the infrastructure for that. None of the practices that I mentioned are active, because the law itself is not enough. It needs to have further legislation. It requires further legislative works like regulations, but it is a difficult process. Why? Because we visited the ministry and asked them how the process is continuing. Before publishing in the official gazette, all the regulations needs to be assessed by all relevant ministries, and all this opinion collections process takes a lot of time. So regarding the super permits, we are in the preliminary stages, very first stages. Unfortunately, it hasn't been activated. I have an investment up to 410 megawatts, and we cannot explain why it's not commissioned so far to the bosses, because in all these projects, the active investors, yeah, there are majority, but we also know that there are investors who are waiting on the standby, and I do not have any possibility. I don't see any possibility of commissioning of any of my power plants in the year 2026. So expectations are there, and within the year we expect all the legislation to be done. If we were to pass the year 2000, miss the year 2026, but for the year 2027. That we expect a really accelerated process. The ministry will have to put a lot of work there. But for the year 2026, I am not hopeful. And also, our region, ongoing wars are waged in the region. And in the last Israel, US, and the Iran war, we had significant problems regarding the costs. And some investors who started from the license, they decided to put their projects on hold, given the increase of the cost of the diesel and the oil in general. As you know, the transportation is one of the major items for costs. So we had a lot of differences in investments and costs. But sometimes a negative thing can have positive impact. What was the positive impact here? Yeah, we know in Turkey we started to reduce the interest rates, and the central bank is delayed to carry out such reductions in the interest rates. With such delays, the investment determination is increased in all investments in Turkey. I mean, when the investments started to slow down, both the Ministry of Energy and the electricity generators started to slow down because the demand did not increase. But next year, after the end of this war and the completion of the legislative processes, the storage investment is to be needed. There will be high demand for them for the next year. Since Turkey's consumption of electricity increased and the power plants need to be commissioned, I'm sorry I did not paint a positive picture for the year 2026, but I believe we will be really fast for the year 2027. Can I continue? Continue for the second. In the second side, there are other problems. What kind of problems? Infrastructure and superstructure problems. Why? Because TİAŞ has been prepared for new investments up to 8-10 gigawatts per year. And with the distribution of these 30 gigawatts in the year 2026, it will be difficult for them to commission all of them all at the same time at the year 2007. In the 10 regions at the basin transformer centers, the TİAŞ wanted the investors to solve these problems, and they wanted to reimburse them through the system usage costs. But these are significant investments. If we are to invest up to 50 million USD for a single power plant, but for basins, the cost would easily reach up to $100 million. The ministry had other studies like EPCR model until the end of the year 2025, but We have been informed that the Minister of Finance is not positive regarding that application. So the investments regarding from TH is continuing for the year 2026, and in the year 2027 we hope all of these projects will be connected, and we know 10 regions have TMA problems, and the investments continue seriously and rapidly. While we are receiving these preliminary licenses, there is a validity period for them. The Energy Market Authority gives us a time limitation up to 2 years, 3 years to reach this, to complete this licensing process. And they started to ask why you completed after 2 years, 3 years, you did not start the investment phase. But a majority of the companies had the force majeure circumstances, and they received the grace periods extensions with the investments, and a majority of them received extensions. Perhaps you have seen on the news that unfortunately certain projects did not receive extensions, and they were cancelled recently. Of course, there will be secondary objection, and the court cases, the processes will be continued. But the actual investors continue. Let me check my notes to say anything else. Perhaps we should give the microphone to the other speakers too. Finally, I'd like to say, as a final note, feasibility of this project, up until 3 years ago, there were real problems regarding the feasibility, and nothing changed in the last 3 years. In a period where the capacity costed a lot, the companies spent a lot of money to have the capacity. And regarding financing, we expect certain efforts from the government. And also, there are a lot of loads in the system usage costs. Perhaps there is a strategy to halve those costs, which will further accelerate the investment processes. Thank you very much, Ömer. Of course, the investors are the people in the field. Of course, this is not a single-sided issue. The financing is the solution, but up until reaching the financing, there are other problems that needs to be considered, and the investors are spending a lot of time to solve those problems. And we can see that the ministry has a positive approach to all this, and which will be solved in short term. More than these problems in your country, as is mentioned, one of our main objectives is to develop the technology and generate, produce, manufacture here, which starts from the R&D. Valuable institution, the Ministry of Energy's R&D Center, Tenmak. Ömer Faruk is from Tenmak here. Here, Tenmak's approach, what's your perspective? Yeah, lithium-ion battery phase is still going on, but it is not a final technology. This is not the end technology. There will be more technologies that will emerge, and I believe there are certain type of technologies that we can domestically produce, and I'd like to hear from you about that. Thank you very much. I'd like to extend my greetings to all attendees. As you know, ministry, the main mission of the ministry is to ensure the energy demand safety, security of the country. With the net zero targets for the year 2053, and to transform entirety of the ecosystem into a national and domestically produced format. To achieve those technologies, the energy, nuclear, and the mining minerals ecosystem needs to be approached holistically. And in order to prevent duplicity in the efforts, Turkey is a nuclear and mineral research institution is created by the ministry. Tenmak is the abbreviation of the term. There are 5 different presidencies under Tenmak. There is nuclear, energy, and the mining. We have specialized institutes, and I am the chairman of the Clean Energy Research Institute. Our final objective as the Clean Energy Research Institute the energy storage technologies, energy efficiency, renewable energy, hydrogen energy, and carbon capturing and usage utilization technologies to carry out R&D in these fields. But you should not only consider research and development as a standalone concept, because as an institution, if you do not transform the R&D into manufacturing and production, it's not something that we aim for now. Perhaps we have been hearing about R&D, we have been talking about it. But what's our understanding of R&D? I'd like to shortly mention that. We need to look at the impact of the R&D on the manufacturing and the production decisions. What's their contribution in the improvement of the legislative improvements? Because for successful implementation of a project, you have budget, human resource, and the legislation. So legislation is an important aspect, and we believe the R&D can be used to improve the legislation and their implementation in the field. We have been talking about domestic production, national production, but what is it real? Is it realistic? And what kind of depth that can be achieved with the R&D? For instance, talk about any product that can be easily accessed anywhere in the world. Should we research and develop those products, or should we carry out R&D works for a product that will be that will make this country pass through another threshold? When we talk about R&D, we also need to consider what kind of activities can be carried out to bring together the manufacturer, the developer, and the investor. This is our understanding of the R&D. As you know, the year 2035 milestone that is discussed in today's session is the first stop in our 2053 targets for Turkey. While carrying out all this, carrying our activities, the first stop for us is the year 2035. And for that year, for solar and wind, we have 125 gigawatts, which is an ambitious target. Our installed power today in the wind is 25 gigawatts, and for solar it's 40 gigawatts. So until the year 2034, we need to triple all these efforts. But I've been visiting Solarex even 10 years ago. There were excitement. There were not so many solar power plant producers, because in the year 2026 it wasn't even 1,000 kilowatts for that year. Today we increased it 10 times, multiplied it by 10 times. Today it's a technology that's attracting a lot of interest from investors and other perhaps. So the future Solarexes will need to talk about different agendas. The reason for that is, yes, solar and wind are important. It's a clean energy and provided a good opportunity for us. There has been a campaign of investment and production, but for certain aspects you can hear the alarm bells. What is that? That's the management of the grid. In Turkey, you know, we have a good potential regarding the wind, and perhaps in certain areas we can consider the wind as a base load, but solar or the wind energy will never be the base load from ministry's point of view. But the continuous supply sources like nuclear, geothermal and other, when you do not achieve the required capacities, you cannot provide the status of basis load for them. Well, how we can achieve that? With the storage. If the solar is not sufficient, the sun is not enough, sun radiation cannot be achieved, you need to store the energy beforehand and then feed the grid. For the storage security, the demand security of the Turkey depends on that. Important. In July 29th last year, Turkey almost experienced a blackout. It was a near miss actually. Of course, we carried out certain studies in our institute and we exchanged our conclusions with AH2. And for the summer seasons, you need an air conditioning. And when the air conditioning demand increased, the supply cannot meet the demand then. Especially the daytimes, we need to have a biases load with standby power. This is why storage is an important and critical sector for us. As you know, in the year 2006, for the year 2006, we had a limit carbon mechanism with the emission trade system, which we need to, which says like steel, cement and aluminium. The sectors that with high energy demand, in order to carry out their exportation to the Europe, they need to provide a green certificate. But our investors, especially in the last 5 years, the steel and the cement producers, I can say, manufacturers, I can say that. Of course, the same applies to others too. Everybody started to install the solar power plants as much as their capacities, with the balancing with the other parties. They start to say, yeah, we are green, producing green. If you are manufacturing cement, if you cannot use the hydrogen, for instance, for cement production, Europe says what you manufacture is not classified as first, the green, but is classified as second. If you are manufacturing in nighttime, for instance, you do not use the solar power, but you take it from the grid and using fossil-based energy there. With the strategic investments in here and with the strict implementation of the SKD, we will further need storage, and the energy that's stored in the daytime will be used in the nighttime, which is an important aspect for the certification of carbon-intensive sectors. So, addressing the carbon emissions in Turkey and guiding the investors to this aspect is important. In the climate law that's adopted last year needs to be strictly implemented. As you know, in order to develop a sector, needs to have two criteria. It's carrots or the stick. Yeah, I've been talking about the carrots, but should I talk about the sticks? The market authority is monitoring the strict implementation of the legislation. As Denmark in the last 2 years, especially in the year 2025, what we did regarding the storage, we prepared the Turkey storage strategies and the roadmap, which is expecting the acknowledgement by the minister. But given the regional developments, but despite the increase in the demand for the fossil fuels, but these are important, and very soon Turkey's roadmap for the energy storage will be announced. We prepared another project financed by the World Bank, which will be announced regarding the hydrogen, which will be announced soon. I'd like to underline a fact. The EMBRA allocated 33 gigawatts of capacity for hydrogen, but all of them cannot be supplied with the batteries, lithium-based batteries. Other thermal or mechanical energy storage systems needs to be used, like the thorium and others. We are the sole test center for the hydrogen. In order to accelerate the development of the hydrogen ecosystem, incentives and stick mechanisms will be used, and we believe this will be a storage medium of the future. The war, globally speaking, this uncentralization of the energy, brought forward the uncentralization of the energy with the distributed storage. And even Iranian missile hits and natural gas recycling power plants. It can cause extreme damages in Dubai, for instance. But with the solar power plants, with the distributed usage of it as the basis load, it will provide security for the countries. In our institutes, in order to ensure guiding the way for the future technologies in the energy, we carry out coordination of the R&D efforts by the ministries, energy, electricity generation and incorporation, AEH. We have a 300 kilowatt solar power plant project for lithium and palladium battery integration project, and it's energy management system, battery management system, and arbitrage. And it's scaling up to the other larger power plants. We have been working on that. And we had a tender in this project, which was finalized, and the national company won that tender. With the war, this has been out of agenda for long, but the rare earth elements and the material technology and the technologies that is needed, but that cannot be accessed in the extraordinary circumstances, we are working on that. There is a large market regarding the storage of the energy. Yeah, many people are carrying out work. But in order to be able to implement the future technologies in our country, in our institute, in our ministry, we are doing our best in this regard. Thank you very much. These are valuable contributions by us. Yeah, these are today's technology, but in the energy market, in order to be able to competitive in the future, we need to work on future technologies. And we would like to thank you for all your efforts in this figure. Ramazan, you are the last but not least. But when you are last, you do not have much to talk about, cover about. But everybody's talking, you have a you have a blank page here. We have war, we have capacity programs regarding the generation, and the government needs to invest, and the investor needs to access the financing. With the increase in the interest rates after the war, it could be a challenging environment for the investors. So let me give the floor to you, and what are the risks and advantages that you can see? Yeah, being the last, I do not have a maneuver area. Regarding the storage systems for the energy production generation, when we talk about all the systems of the entirety of the storage, I consider the storage system as the lost child. Why? Because renewable energy and continuous generation, natural nuclear power plants, and the natural gas power plants, they are all. We are coming from Ankara, and when we talk about the solar, Ankara cannot generate now with the lack of sun. So the interrupted energy resources needs to be baseload power plants to generate electricity. Why we did not talk about the importance of it? Because the lithium phosphate, iron phosphate technology is it's the most feasible system right now. Technology, the lithium iron phosphate, with the ongoing R&D efforts, as Mr. President just talked about. But the business world only embraces the commercialized product. When we talked about it, we were talking about $1 million USD for megawatts. But when we look at the Chinese products in the market, it starts from 100,000 USD up to the 200,000 USD. With the cheaping, with the cost reduction in the systems, all the countries, all the economies are orienting towards the cheaper renewable energies. When we look at the Hormuz Strait today, up to 80% of the natural gas is produced by Qatar. With the problems that going on with the Strait, they are reflected in the cost of energy in the globe. So when we talk of, we need to look at domestic energy resources, with the cheapest energy resource being, and with the Ukraine-Russia war that has been going on in the whole world, an energy war has broken in the globe. In the industry research with the Chinese competition, the critical items are important. So the storage systems, along with the renewable energy, have become a solution, viable solution. For the year 2025, when we talk about the storage capacity allocations, what we were talking, yeah, it is expensive, how we can do it. But today, it has become an inseparable part of entirety of the systems, from vehicles to the transportation. And the sources like generators.
Therefore, the storage systems at this point is important. In energy efficiency, as my friends have pointed out. In order to realize these investments, there are some problems like the concrete problems, and we can say that the biggest problem is that the energy, the lack of capacity. We are talking about 8,500, 9,000 kilowatt of energy installation is still awaiting, and there's $150 of that. And we can say that our objective is to realize these investments. And of course, these investments are all ongoing. With the EMRA and Turkey, with the vision, we had this vision defined in 2022. And of course, as the International Energy Agency pointed out, 6 trillion per hour kilowatt investments are still ongoing. And we can say that in the upcoming period, energy efficiency, energy storage system will be in that. And it's like a YEKA energy. There will be storage tenders to be held, and electricity selling unit price. There we are talking about 7 and 13 cents. So we can say that's in the world 1.5 cents, 3.5 to 5 cents, and it could go up to 6 cents with the local contribution. And of course, with that, energy cost will decrease. And in terms of the investors, there are the energy investment systems, and when we check this out, when we go to the basics, through the production of batteries, and for us, for this cell, post-cell packaging establishment, we can turn into any opportunity. Of course, one another problem is the finance, and with the finance, we can say that it is about all the funds. The best ones are the energy systems, and of course, when you complete the licensing and generation procedures vis-a-vis a bank, you need to have a feasibility in terms of funding. Even if the loans are very high, there is this energy sector. We are talking about 33,500 capacity that should turn into the investment. It's about having an ecosystem. And of course, in order to have this, the banks are working to realize this. And in terms of energy transformation, this is very important, because when we consider the war recently, what the energy, if you're having a cheap energy generation, you will be in the leading state. And of course, when we check the US, which is the second largest carbon footprint producer. They're withdrawing from the convention, and we can say that the world will have these investments. And if anything else that I missed, there is one thing that you missed. It is that the consumption and with the collection in terms of self-consumption. There is this netting, hourly netting. Maybe we can talk about this and we will finalize. This netting is hourly netting is important. And for the ones with the license project, of course, the EMRA is making this, the tenders, and there's this capacity. And like last month, this is a capacity announced from a generation power plant with a 3,500 kilowatts for settle net or net settlement, and this industrialists. They have this capacity at the most. Therefore, with their energy, they're trying to decrease the energy costs, and they're trying to compete with China and US. And of course, there could be a better capacity, and these investments can work. And as you pointed out, there could be this hourly net settlement, and of course there are activities in this regard. The unlicensed project, how they can work, and this storage projects can be added to that. And this 13.3 cents, and they have started this, they have finalized the project, and there could be a solution with these infrastructures. There is this hourly net settlement, and we can say that in terms of the renewable energy resources, there is no change in this difference in the start of net setting. It is a net settlement. We are lagging behind. What we produce and what we consume are netting. However, how can we establish these projects is an important subject. Of course, it's about the capacity to have this the solar power plant and check this one, and we can say that at this very stage, and the fossil fuels, even if the power plants are difficult to have, with this once with the hourly net settlement, this could increase more. And in terms of the software, we can say that it will be even easy. It will be even more easy, and I think that will be more important for the sector. We are talking about large projects. We are talking about 100 megawatts, and when you check this, like the plants and factories and houses, there is a huge installment, and of course this should be used and should be monitored. And we can see that there is this software. We started a bit late, and we're trying to finish on time. And thank you very much for all the valuable information that you provided, and we can close the session right now. Thank you very much for your kind attention and for listening to us.
Shall we begin? Okay, welcome everyone to this session. Thank you very much for being here. I believe the exhibit part is going very good and with intensive attendance. And we have a really loaded panel today. We will talk about the energy transformation processes. The storage is one of the most critical parts of this process. What is installed power? How much we can generate with this installed power? Very important subjects. But today, one of the most important subjects is how we can achieve flexibility in our generation and our participation to the system, the energy storage systems, how we can improve it. Or the energy storage systems that are installed or that will be installed, how we can improve their feasibility. This is what we will discuss today. In this grid with the increasing renewable energy fed to the system, the controlling of the storage is one of the most critical components of the system. And the storage facilities are important in this respect. This is the subject of today's discussion. We have valuable speakers. I'll introduce them briefly, and after my questions, I will be Mr. Abdülhamit is representing the business models and investment approaches. Gökhan Bey will be talking about the standards supervision and the in-field implementation. And Gökhan will talk about the AI in the field. I'd like to welcome them on. Our objective is not only talk about energy, but throughout this value chain, what the value we can create in this energy storage system, and how we can maintain the systems while creating such values. I'd like to start from Abdülhamit, the CEO of RD Energy Technologies, and he will talk about. He experienced the transformation in the energy sector himself. His journey in the energy, starting from the natural gas systems, is continuing with the energy storage system, with the wind, solar power plants, and he is also working in the new generation nuclear power plants. Investment is an end-to-end solution providing company, and Abdülhamit has been in the center of the transformation process that we are talking about. In the sector, we frequently say Turkey can be the energy storage basis of the region. This is an ambitious target. From your perspective, why Turkey can achieve this objective? Thank you very much, Batur. It's my pleasure to be here. Welcome all. I am Abdülhamit Turgut Bağdat. I am the CEO of the RD Energy Technologies. I am also a member of the executive committee of EDADER. I'd like to thank Batur and other speakers who are all valuable. We know them in the sector. Turkey has ambitious targets, yes. Turkey will become the base of the energy storage in the regional scale. It's an ambitious target, yes. On this regard, in the years 2023, we started to work on the energy to talk about the energy subjects. There was an energy storage exhibition in Istanbul, which we attended, and we attended another exhibition, expo in Dubai, with the international participation. You know, all the developments in this sector is starting from China. China is the RD center of the world. So we went to China and contacted certain companies, and for storage technologies, in Turkey we are starting to manufacturing process. So we would like to monitor the progress in China and how we can implement your technology in Turkey. We were in China, I was presenting, and the owners of the company, Chinese company, were there. I was explaining them these many licenses were obtained. We have this installed capacity with the gas, with the solar power plants, and with the storage power plants have the capacity of this. And in the middle of the presentation, the Chinese boss stopped me. Yes, we can see that you're determined to work in this field. But you should not limit yourself to Turkey. We need to work on Turkey as well as the neighboring companies. I was on the stage presenting with the global map, the map of the earth on there. And when I look at Turkey on the map, what are our neighboring countries? We have Balkans, 6, 7 countries, Balkan companies. On the upside, we have many countries like Bosnia, Azerbaijan, Bosnia-Herzegovina, Azerbaijan, Iraq, and Iran. We have deep-rooted cultural connections there, and we know their energy profiles as well. And when you look at Saudi, there are other countries. So I thought about it, what he said. In the storage side, can we be partners in these countries? Yes, indeed. Regarding the generation and consumption of the energy, when you look at the 15, 16 countries, entirety of them do not equal combined to Turkey. So this shows perhaps sometimes people ignore the potential of Turkey, how big a country regarding generation and the consumption of the energy. But when you look at the map among the 17, 18 countries that are neighboring Turkey, we have figures equal to all of them combined. So regarding the generation and the consumption, Turkey is a giant, and for the storage side of the energy, Turkey is the only country that can serve as the basis, regional base. I told him, thank you. I still told him, we need to focus on Turkey. All our motivation is towards Turkey. And only after achieving a certain success in Turkey, and after starting manufacturing all these materials in Turkey, we can then focus on other countries. I believe this why the association's motto is the energy base, regional energy base. Turkey is the motto. When we talk about the wind and the solar power plants regarding storage, the total licenses that are granted is over 33 megawatts, and we have over 220 installed capacity. You know, we have 125 installed gigawatts installed power plant, and which is 26 gigawatts of solar power plant and 15 gigawatts of solar power plants, and there are new licenses that are issued. So there is a preliminary license portfolio of 33 gigawatts. I'm sorry. And when we look at, there are other projects that have completed their preliminary licensing processes and will start in the generation. And as of the year 2026, we 500 megawatts of wind power plants and 1,500 megawatts of solar power plants, of the 2,000 power plants. And the solar and wind power plants with storage capabilities that completed the preliminary licensing process. As you know, there is a time period for the preliminary licenses. You need to complete entirety of the permit processes in a given time, and after that they will start from preliminary production and then generation, and they will establish their generation facilities along with storage facilities. Before coming here, I had the chance to look at in more detail. We will talk about the ancillary services and arbitrage today. When we talk about ancillary services, all those storage facilities, are they qualified as ancillary services? No. When we look at them, the traditional, conventional solar power plant and wind power plants are not qualified regarding to the ancillary services. In the past, we had an operators in the solar power which all their entirety of the process did not qualify as an ancillary service. But when you look at with the integration of the storage system to the power plant, the solar and wind power plants, they turned into power plants that can qualify as ancillary services. But there is a quota here. If the power plant has an installed power of over 30 megawatts or more, can be subjected to the ancillary services, and the power plants with less capacity are excluded from ancillary services processes. When we look at the power plant and the wind power plants, solar and wind power plants, what is their proportion to the others? 33 gigawatts of preliminary license portfolio, 19 gigawatts of wind and of which 17 gigawatts, meaning 92% of the wind power plants, and totally 14 gigawatts of solar power plants, and 10 of which will qualify as ancillary services and will contribute to the ancillary service processes in Turkey. Thank you very much, Abdülhamit. I'd like to continue with Erdal. Dr. Erdal Uzunlar is the technology development specialist in the Max Energy. He combines the mechanical and the chemical engineering specialties. He has extensive experience in the private sector as well as in the academia. And more recently, he has been focusing on the AI and implementations. Welcome again, and I would like to start with the AI for the energy storage system implementations. When we look at from the ancillary services and the arbitrage, what are the AI applications? If you have concrete examples, it will be lovely. Thank you very much. First of all, welcome all. Thank you very much for being here. I'd like to thank Batur for giving this opportunity. I am Dr. Erdal Uzunlar. I am a chemical engineer and a mechanical engineer. When we look at today's global sector, the electrochemical energy storage systems are important critical components of the energy storage systems. When we look at the batteries are electrochemical devices, and the owner of the batteries actually pays for the chemical reactions that occur within the batteries. With my educational background, I have the opportunity as a chemical engineer. I know the electrochemical reactions that occur within the battery, and as a mechanical engineer, I know how the grid will be impacted by this battery when it's combined in a system, and how the market will be impacted by it. So when you look at it, the energy storage systems have a lot of advantages that they can provide for the arbitrage and the ancillary services. What we are trying to achieve, to use the same battery capacity in both arbitrage and the ancillary services. So create value in different markets and different systems in the form of value staking. You have a limited battery capacity, 100,000 megawatt hours or 50 megawatts of energy is corresponding. You want to use this capacity in both for the ancillary services and for the arbitrage. When you look at it, there is a conflicting area. There is a conflict there. If I were to explain it, you can give the examples. The frequency regulation wants from battery to be ready at all times, because when the frequency downwards, you need to take certain measures through the battery on the grid. What it means, you need to be ready for me. You need to preserve certain reserve of the energy. So SOC levels that we mean the measurement of the battery charge levels needs to achieve certain levels, which is 40 to 60%. When Houston?
Yeah. Actually, battery, when needed, you can fill it so that then you set to be an area which is empty, and you can drain the battery if you wish. And in addition to energy reserve, there is the power reserve. Some part of this power reserve all the time should be ready for the frequency regulation. If there's a 10 megawatts, you need to spare it for 5 megawatts for energy regulation. And in the arbitrage, this is a reverse, because in arbitrage, what you want to take it from the battery is that fill it when it is cheap, and when it's not cheap, you need to drain it. When in a battery, you can say that you can get the maximum efficiency, and the SOP should be from 0 to 100. So that in the arbitrage you can maximize the income that you want to get This is the AI is trying to solve this contradictory two issues. What it is, provides is to learn it, to foresee it, and to optimize it. And of course, in order to talk about these, we can say that there is this forecasting, a battery system or energy management system should be able to foresee as follows. What will be the energy prices in a few hours? Will there be a frequency regulation need? The renewable energy, should it decrease or not? This should be seen in the system. And if you don't know this, you can go there and you can, if there is this signal system, and if you do not, if you have a spirit with the regulation, then you will lose money. The system should be able to foresee it. In AI, there are LSTM systems and XGBs like GBM methods. And there are the SGR models. They're using the artificial language models as well. And the other one is the co-optimization. So your reserves and for the frequency regulation for arbitration, the charge and discharge cycle can be optimized. And you need to include the aging of the battery system electrochemically when it is charged and recharged. We're talking about an aging system, and there is an optimization problem. So again, you need to trade off in this regard. So at one point, there is this income you get generate from arbitrage, and there are the ancillary services like the arbitrage, and there's a degradation of the battery, which you will write as a minus. So you are trying to maximize this, and there is the limitations of a market, and within this scope, you can optimize this. And there are the classical systems that are using this for optimization. They handle it statically. The difference of AI is that it looks at it, handles it as in an optimized manner in every 15 minutes. So they make the optimization in every minute or in every 15 minutes. And for objective function, the degradation is important. And of course, the degradation should be taken into account by this, and it's present with the charging and discharging cycles. In the cathode, the active material you use, this active material, there is this mechanical stress. It's the loss of active material. There is such a concept. You need to take this into account. And of course, when you cycle the battery, the lithium inventory decreases as well. And there is a loss of inventory, lithium inventory. And for charge and discharge cycles, the electrolytes are lost as well. There is electrolyte degradation. So these three mechanisms is for the optimization, and for decoupling that, there are some electrochemical deep models in the literature for electrochemical engineering in Georgia Tech. And for my PhD, there is a DFM model. It is PT2 model, and one of the developers is Thomas Feller in this regard, who came up with this model and solving this through AI. With the AI structure, it is one of the systems, and the other is learning. It's about managing uncertainties. Nothing is certain in the real life. The wind, it cannot be blown, and there could be these clouds, and they can go. You need to come up with the possibilities, and the AI distributes a risk through learning this. Could be aggressive, could be conservative energy policies. And if the volatility is high, what you need to do is to go with the side or ancillary markets. And if you have a system which is there, you need to go for the arbitrage. And it is about reinforcement learning. It is a method that has been developed, and there is a deep Q networks, actor-critic networks methods. The system learns from the market, gets a lesson from the past experiences. So it's not checking the instant income. It is for long term, because there's a degradation of the battery. With these hard services, there's a 4 layers, and then AI is solving that. And if I'm to give a concrete example, in the market, what is we can talk about 3 major players. One is Tesla. There's Autobidder and the Opticast used by Tesla. The other is Fluence, Mosaic, and IQ. They have these 2 models. The other one is Wasila. It's a Finland company. They have Bitgas and DMs services. In order to concretize that, there's a benchmark a case study made by Tesla in Australia, and it is conserve power reserve study. Power reserve has a capacity of 200 megawatt per hour and 150 megawatts per hour. It's a storage area. And Tesla, in this regard, with Autobidder and Opticast, they deploy these methods, and there's, in terms of frequency control, there's a decrease of prices. So we can say that with the battery energy storage system for frequency regulation makes an operator, and the grid makes an offer to grid operator, and it's a very low one, and there could be natural power plants, and it decreases reduces the cost. And in terms of income, for arbitrage, 50 to 60 million USD, $6 million for Australia is taken, and the ROI is in 2 or 3 years. The return of investment is 2 or 3 years. Fluence and Wärtsilä, the systems are not open, but we can say that with the use of AI, with using these methods, there is a 10 to 30% of income, additional income generated. And this is a concrete example. Thank you. We will continue with Gökhan Bey. Gökhan Durukan has a standardization and field experience in solar energy. He is the one founder of the laboratory of the battery, and in the supervision areas he worked actively for years. He was the general director in the POPRI model, and he established RAM World, and he is continuing his activities in RAM World. Once again, welcome Gökhan Bey. Gökhan Bey prepared a very nice presentation. First and foremost, in terms of energy storage, when there's an investment wave, the standards can be overlooked and ignored, and for security, performance, and monitoring, of course, there are critical national and international standards that he's going to talk about. Thank you very much, distinguished participants. On behalf of my company, I'd like to salute you. The storage systems is integrated to solar and wind energy. And in the national, international procurement and design, it is very important. There's this structure, and in the design of this structure, in technical specifications, and of course in the import, there are certain procedures that we need to be careful in terms of customs, in terms of the quality, and there are national standards that are defined. Of course, in Turkey, with this, there's this system we are working with Erdal Bey, and we have other investors as well, and we are working in this regard. And in terms of this generation and production, what do we get? And about the certificates, what we are going to get in the fire, what are the performances, and these are the electro-technical committee. These are defined, as Erdal Bey pointed out. These are degradation, thermal cycles, the heat and the risk, and we can say that there is a risk analysis for us. And in Turkey, there is this system, the risk analysis and the standard. In terms of standards, I prepared a very short presentation. At this stage, on the side of solar energy, there is a PV model multi-component structure, and within that structure, of course, you see the main standards, and there are many standards that are referenced for the storage services. We see that within the storage system, with the integrated structure of this, we need to touch on many standards, so that I'll talk about these standards. And we can say that there is a 62933 standard, so that we can use a common language. It's about the terminology, and within the system, in the technical specifications, language, terminology, security, and performance, talks about this. And there's a system once, and there is this one, there's -1 standard is about terminology. The other one is about the performance requirements, and these standards has 200 references. 62933 contains 2 standards. The energy wars, there is this standard wars as well, and it's about the conditions. And of course, in technological provision, they start better. And of course, these producers should be in the standard committees. And of course, Energy Storage Association, the activities that we carry out is about the committee or opinions provided, and the standards we have. It's very important for us to play an active role in the standardization. In terms of the academicians, in terms of producers, we can all be a member, so we can get give opinions to them. And when you look at the standards, there is a 62485 standards. It's about the battery system, and it's a serial standard. There's these security rules and there's a type standard, and the thermal cycle degradation. And in terms of the certification, there is a 629 619, 62, 620 is the standards. And of course, these are the certification standards that we need to be careful. And for battery management system, there is the series standard 62177. It's about for the BMS. We see that, and the standards of Europe make a reference to fire, and in the US These are the major standards, and of course there are the sensors, and with that there is this battery system, and of course there is the reaction to fire, and there is the type standard. There is the standards that we have. There's the structural security. For the design security, it is the standards that we have. We are designing and we will commission the system and establish the system. And for sustainable work, there is this and the grid, and the integration is important. There needs to be the right connection of the grid. Of course, we have the standards of 61727 is there with the battery system, the performance and the commissioning of the system as well, and the acceptance test. Of course, the test should be with the accredited organizations, and of course there needs to be the commissioning test in the field. They are very important. Periodic examination of the system, these are very important, because when you don't know where you start, and of course the periodic degradations are important, and of course there is this statistical information. This standards 61313, and if there's a standards as a table, of course from a system to the integration, of course the main standards are summarized in this table. The standard commission until the commissioning period, and the technical specification and periodical examination, we can say that these are all very important. Thank you. I finalized. Our speakers are speaking like poets, and everyone, we can hear them until the morning. I don't want to interrupt you, but of course I'll ask a question, but we will finalize at 5 minutes, and I'd like to say a few minutes when I'm closing this session. I'd like to combine two subjects, and I'd like to ask as follows. Of course, in terms of batteries and about the battery plants and facilities, there's expectations. Speakers touch upon this, and there's ancillary services and arbitrage, how our investors can make income in that. And we can say that about the battery system, what are the opportunities that you see? This has been a very enjoyable session. I listened to very good stuff from speakers as well. And there is this idea that we have, how can we make it the investment, how can we earn money in that regard. Everyone is trying to come up with the right models, and these models are very important. And when you look at the income, what are there, we can put it into two. There are these arbitrage services, and of course this ancillary services is divided into two: primary and secondary frequency control. And when you say secondary frequency control, I don't want to go into details. In the TEAS has now prepared already infrastructure for secondary frequency control. They are going to update it, and of course for the secondary frequency control, they will be in line with that for the automation system in the power distribution center. There's this command center. There's this sending signals, and there's this automatic generation control software that TEAS has, and this is software is working for that as well. For the I will not go into the details of secondary frequency control. Maybe if we can get earn money from the primary frequency control, and we can very fast from there could be a charging system, or there could be energy is distributed to the system. Primary frequency control, there are two ways that to earn money. One is that you can have this power plant with storage. You can make it wait for the primary frequency control because of the capacity allocation. There's a certain money paid to you. The second one is about the primary from the contribution of the primary control frequency. Because you loaded the frequency, you get money as well. Everything seems very nice right now, and of course you have the power plants with storage, and there are investors there as well, and it seems that we're going to earn money from that. But what I think, my opinion is that the hourly frequency control of need of TH is set already. There's EC vehicles, and there is the electricity age. The consumption is increasing. The electricity is the main material right now. But as for today, the network and the primary control frequency control need is set and defined. And there are hydro power plant and thermal power plants, and thanks to their contribution to the primary frequency control, they earn money. And we have the solar power plant and the hydro power plant and thermal power plants. We are in very good in this regard. And of course, if as the number of power plants with storage increase, because the need is set for primary frequency control, as the supply increases, what will happen? Automatically, I think that in the upcoming 3 or 4 years, I think that the ones the power plants with the storage established in the first stage, they will get money. But these power plants are 20-25 years of age, and I foresee that there will not be money made in this regard. And for arbitrage, there is a bad picture before us, and there are the reasons of that. For arbitrage, the initial investment cost is high. China is the main supplier in this regard. We went to China, as I pointed out in my speech. We talked to the power plants with storage. We got offers. I can summarize the prices. For 1 megawatt for energy storage, the factory outlet price is 75. And as you know, that there's this 30% of customs tax in Turkey imposed. And when you add it to $75, it is $100,000, and you just transport it. There is the workmanship and the labor cost, and there are the requirements that you need to go through. So 123, this is the 100,000. This is a DC. I have 30 megawatts. In order to get the outlet power in AC, I do not install 30 megawatts. And as Erdal Bey explained in detail, so the storage is a very sensitive. There are too many regulation parameters. And there's AC, DC, DC, AC transformation records. When you check this, when you take this into account, in order to have 30 megawatts, there needs to be 40 megawatts of installed power, and there is the surplus of 30 megawatts. And my cost was 120,000, and now it is 165,000. And there is the loss of DC, AC. And there is the AC-DC transformation loss. The cost is 92, and we foresee it is $180. When you add this as well, it is $160,000 for an efficient power plant, 175,000. And there is the power converter as well, because the inventors are stopped right now. When you just combine these two, this is a new term that we have, and we can say that per megawatt it is $50,000. So the storage on average megawatt cost is $225,000, and there is this supervision document. There is a tax as well. You can use it in other places as well for
$225 for 1 megawatt, and I have a storage life cycle with 5,000 cycles. It's less than 80%, and with up to 6,000 cycles is approximately 60%. So they have a guarantee for the 6,000 cycles. So we have the storage at 1C rates have 6,000 cycle lives. So when you divide it, you by average an amortizement cost of $35 to $40. So this is an arbitrage cycle cost. When I fill and discharge my storage, I have a $40 cost. When you look at the energy market for the APIs, you have a PTT price throughout the day, which increased up to the $100 USD. Well, in the past, it was $80. So 1 hour of energy that I can sell to $80 US, it costs me $40. So it is difficult for me to sell it to the 82. I need to sell it to the $60, $50. And as you all know, the electricity market works on estimations. They publish estimations for the next day. So this is the result that's created. So there is a unforeseeability risk that I can see in the arbitrage. In the future, with the reduction of the costs of the storage, and I believe the $40 of cost will be reduced, which will increase the profitability, the margins. And in these power plants, the AI is supported, as Erdal mentioned, the software and technologies and their integration to the system and their accuracy in their estimations will increase the income of the power plant and the arbitrage in the future, not today, even if not today. In the coming years, it will be increased, and this technology will be more feasible. This is what I believe, honestly. This is the biggest risk here. The estimation and the uncertainties in the market and the prices and the difficulties in operation. We talk about it everywhere. In the energy market, when you are charging the energy to your storage, you have negative prices expectations. There are rumors about it. Europe has been talking about it, and negative prices. If the energy market activates them, if I gain income whenever I charge my storage, yeah, it will be a benefit. If the limits are exceeded, you can achieve certain margins throughout the day, which can create an opportunity for the battery manufacturers. Erdal, I'd like to combine both questions, and I'd like to give you an answer within 5 years. There is a discussion about the battery passports. What is it? And investments, what kind of technical infrastructure will be needed for the investors regarding this battery passport? And in the next 3 to 5 years, is there a possibility for the AI to change the game in the storage systems and the AI applications? I'd like to hear about them. Let me start from the first question, the passport. The battery passport is an EU concept that will allow digitally monitoring the information regarding the battery. Throughout the life cycle of the battery, all the data will be stored in the system. We can think about it like that. When it was started, the law was enacted in the year 2023, and the period between 23 to 26 is considered the preparation years. It will be it will be enforced in the year 2027. So the battery manufacturers need to comply with this law. What are the batteries that are included in this concept? The batteries manufacturers or users of the batteries with a capacity of 30 megawatts, the electric vehicle manufacturers and BES manufacturers will be impacted. The objectives of the system is the traceability and the transparency and the sustainability. What they are trying to achieve, the information regarding the battery, the data of the battery will be transparent. Who is the manufacturer? What's the manufacturing year? What are the raw materials used for the manufacturing? And the raw materials that's being used for the production. What are the processes that were applied? What is the carbon footprint? What is the health status of the battery? What is the current capacity of the battery? All of this data will be stored. This will be a system that will be ensuring this. When we talk about the battery passport, the manufacturers or the users of the batteries, they need to go through certain digital transformation. You may see here to the cloudware. So the data governance system. So this is a 4-layer system. And basically, what needs to be done, the battery is not only an electrochemical energy storage device. More than that, it will be a data generating, traced digital tool. You need to be able to govern it. When we start from this level, what are the data, what is SOS, what is SOH, which are subject to the smart applications. Then you look at the side, why these cycles were applied, what the load profiles that have been used. When you look at the cloud side, the batteries, how the data of the device is processed, where they are stored. When you look at the data governance, what are the data of the battery? Are they kept in a standardized with the ISO standards manner? Then, if and data out it was to be carried out, all of these standards can they be achieved? So the manufacturers need to comply with all. They should have started all the preparations. As the company, we have started all of these preparations, which are still ongoing. And this battery passport will be enforced in the year 2027, and we are already ready for that. On the other hand, we need to also underline the fact that sometimes the manufacturer considers this a burden. The battery passport, I mean, because when you are producing, when you are manufacturing, you need to invest in the infrastructure, you need to create new teams. Yeah, there are challenges in the implementation, but all those challenges can be transformed into an advantage. The crises are the birthplace of the opportunities, as we all know. Regarding the infrastructure, it can be stipulated that the batteries used by the electric vehicles, when they reach the 80% of their life, they are considered a risk. But the batteries are not that, actually. Especially the CNI energy storage. They can be used for the CNI energy storage. So when you look at the second life side, the battery passport will provide transparency, and when you achieve the transparency, you have a perception of the price. So you can be easily learn the price of a used second-hand battery. More than that, of course, there will be a market that will be created by this. And that will be an exchange, the merchandise of the batteries, and also the companies, there is a Green Deal that has been introduced by the EU, which provides certain reporting obligations to the companies, and this will provide an advantage for overcoming all the challenges that will be introduced by the Green Deal. So what do you expect for the future? The second part of the question. In the future, I believe the AI, like in all fields, in the battery level side, it will go down to the molecular levels. This is my assumption. When we talk about the battery materials like the cathodes, its suitability, appropriateness, then we are assessing their suitability on computer. We use the analysis of the Schrödinger and adjacent estimations of the Schrödinger formula. With the advent of the AI methodology, the data that we achieve through this test, we can get those data in a more accelerated manner. So it will shorten the processing time for your things. When you look at the functional theory, you don't have to solve a functional theory model. With the use of AI, you will be able to solve it real fast. With the AI and the material probabilities, their assessment on the laboratory setting with the robotics. With the AI model, you will have a combination of a material and the robotic systems will build everything and test them automatically, and they will feed the results of the testing to the AI system, thus achieving a full life cycle. So I believe the AI systems will turn into the laboratories. With the introduction of the sodium-ion batteries, there is the iron-air batteries have been introduced in the US, and they signed the contract worth $1 billion USD with the Google, with the energy storage needs of the data centers. So all the chemicals, all new chemicals, will come to fore in a faster process and turn into the products in the future. This is my prediction. Gökhan, I'll give you 5 minutes, starting from the investment period and including the operation and the maintenance period. What are the most frequent errors? How those faults and errors and gaps can be remedied? And what are the control processes, if you can talk about them? The first error is in the design. With the design errors, when you have the button, start the button your shirt wrong, then it's containing problems, which also affect the control and the technical documentation and the certification of the batteries. You need to have the correctly with the PMS architecture and the protection scenarios properly designed, and the manufacturing design reports needs to be properly implemented. And also compliance with the standards are important, as I mentioned. When we look at the mechanical side, both the layout of the battery and containers and their statical structures and the ventilation and heat management within the system as well as within the facility are important in due consideration with everything, including the wind directions, and the physical situation of the field needs to be considered. We have an installation over 200 megawatts. I hope this year we'll see new installations, and we will commission up to 1,500 megawatts installed powers. The important thing is to avoid any sessions that we will discuss any fires, for instance, due to the mechanical problems in the power plants. When we look at the wind power plants, the power plants that were demounted after 1 year, some of the power plants give more than 20% losses. When we look at the storage sector, it's a new sector, newborn sector, with the standardization and design appropriately. We will have the opportunity to proper investment and operation with the technical risk analysis, and the system architecture will provide the system feasibilities. This is important. Yeah, of course, we created, we commissioned. Is it then? No, the life started just again with the 6,000 cycles, 25 to 30 years of warranties. Entirety of this process constitute the operational period, with the correct service for user, with the spare parts manufacturer supplier in Turkey, and the design of the operation team of the facility is important for the system's life cycle. With the carbon footprint, with the for the protection of the system architecture, with the IACD 446 standard is important. With the photovoltaic thermal, with the performance tests, electrical inspections, and their documentations are regulated in the standard. Everything needs to be documented every year throughout the operational period by accredited bodies. In Turkey, of course, development of each sector, we have a lot of, the number of consultants and experts increase. With the accredited compatibility assessment bodies, their monitoring, traceable monitoring is important to ensure technical and legal protection of the investors. 10 years ago, when we talk about the feasibilities, we used 1 billion USD for investment for the feasibilities of storage facilities. So when we were talking about it, we thought, yeah, it's not feasible. We started to monitor the technology. Is it the future? Are we ready for the future? We were questioning ourselves as the actors in the field, actors in the sector. But we have seen the future has come. The technology is at feasible levels, but they are not they alone are not important, are not sufficient. It's important to create the trust in the infrastructure, but the most important, the correct business model with the support of the market. All of these topics were discussed in this session, and I believe all of us, a new question marks arose for all of us, and in the future all these questions will be answered. So this is a new sector, newly established sector, and the sector will be developed by those who are currently here in the attendance in this exhibition. And believe me when I say this, everything that we discussed is being currently discussed in the booths in the exhibition area, exhibition hall. How the regulations can be revised are being discussed. Today in this panel we have esteemed and valuable speakers. Thank you very much again for participating today, and I would like to thank the speakers as well.
Our session. Today, as the Energy Storage Association, we are hosting a very valuable speakers, and we're here on the stage with you. Today, we are going to be talking with local and global players, important panel, inverter, battery sides. We're going to be talking about the processes, the current issues, and the added values that they provide. They're going to be sharing their valuable information and knowledge with us. First of all, I'd like to leave the floor to Emre Bey to efficiently use our time. Emre Bey is from Fellow Energy, the general manager, and at the same time, he is also, as you know, one of the leading companies in a local panel manufacturers. He's also an energy investor. HETE, we know from the global market in Turkey, and at the point we have reached today, they are within a process of becoming local, and local production panels are continuing. And also, as an investor, today we will be listening to his views. We want to listen to his views, how this transition is being carried out, how they've contributed to becoming local, and also up-to-date information and their added value in local products. So the floor is yours, Emre Bey. Thank you very much, Can Bey, for your introduction. First of all, I'd like to welcome you all today. Can Bey, as he has mentioned, we are also at the same time as an investor for approximately, we are a company that has been manufacturing in Turkey for the past 10 years, and maybe it will be worth talking about from the past. In 2024, I'm sure you know, there was a change of regulation, and in Turkey, the unlicensed projects, if you wanted to benefit from incentives, there was the condition of manufacturing in Turkey, and obviously it was the start of future possible regulations, and obviously from VAT incentives and also income tax refunds. Obviously, investors had to obtain panels where the cells were produced in Turkey. There was a regulation change in the past July. And obviously, taxation increased, and local part supports and local conditions, and all of these investment incentives were showing us the way that, on a macro level, that Turkey wanted to head. Obviously, we were heading towards an area where production in Turkey would become a necessity, and as a company, because we export mainly to America, we had cell production, and we increased our capacity, and in the past September we began this production. Obviously, in total there are 40-50 manufacturers in total. Obviously, cell production is something that requires so much more know-how, that has high investment startup costs. There wasn't much opportunity for many companies to enter into this arena. As Can has mentioned, there are 5 active companies carrying out cell manufacturing. We can talk about, for each factory, a 1 gigawatt capacity on average, and it is sufficient to supply the local markets. And I do not believe this regulation has been created just for the local markets. We know America's approach to China. We can see how they're becoming harsher with their regulations in that regard. It's a 50 gigawatt a year market, so we require these suppliers, and I think Turkey is in a very strategic position in this regard. Many of the manufacturers I've mentioned also have incentive under HIT 30, and they are required to reach a 5 gigawatts annual production, and we have 20 to 30 gigawatts that we are going to achieve over the years, and this is much above our local market. And obviously, as a result, the export market has a great potential for us. Maybe in the coming periods, not just ingot, but towards silicium, we will increase technology. We will come to this position where we are locally producing this. That's the producer, the manufacturer side of things. On the other hand, the investor, I'm sure you already know, and the solar plus storage side, we have projects that we will be establishing in the next 3 or 4 years. When we use local cells and local panels in these projects, there are local component supports with various coefficients, you'll be selling your energy at a higher cost. If we roughly make a calculation between imports and local production, the cost difference, obviously, your initial investment will increase when it comes to local panels, but because there's no VAT, there won't be a huge difference. But also, together with the income that you'll obtain from energy, this $50,000 per megawatt investment will return within 3 to 4 years. Currently, with storage facilities, there is a local component support for 5 years and a 10-year local contribution when given to the local grid, which has a positive impact on local investments. I'm sure you're aware that the projects recently, we have a lot of tenders from the ministries, and if we look at the demand, the next 3-4 years, 90% will be with storage. And this is now, there's now the condition of 75% local cell production. And as a result, you have to work with suppliers that can provide for this. And finally, what I want to add here is that I've only talked about it on a cell basis, but our ministry is trying to create an ecosystem in this regard. About the glass and frames we utilized last year, anti-dumping investigations were carried out, were commenced, and the aim here, the objective here, was to increase local production. And at that point, if we become able to produce all other raw materials, not just the cells, then the previous problems that we have faced, like with China, we will be in a stronger position, both in local and international markets. Our expectations here is not to have many manufacturers, but for a few to be added, to continue 5 or 6 manufacturers. Obviously, those with their own cell production, they can be a lot more competitive and lasting in the future. I just want to wrap it up accordingly. Thank you very much. I have one more question here, actually, which is, here in Turkey, regarding this local panel production, we already have the objective of reaching a significant capacity. In the next stage, maybe we will have an excess, and I don't believe that you have only made this investment for the Turkish local market. Are there any local panel manufacturers in Europe? At what level do they carry out their manufacturing? And what is your foresight for the European market? Can you mention that a little bit? Especially the developments in China. I just want to briefly touch upon those. This excess that we're experiencing on a micro level, China is experiencing on a macro level. For the past 3 or 4 years, companies are suffering significant losses, and where some are actually failing. We're in this process. For the past 1 year, in this free markets, they've started to get involved, especially in Europe. I'm sure you're aware the prices have dropped to 9 to 10 dollar cents, and China is trying to regulate this. They're telling factories to lower your capacity by half, work not only in 3 shifts but 2. They are trying to lower their provision and increase their prices. So we've started experiencing these increases in the past 2-3 months, and in the coming periods, we believe that panel prices will start to increase from a downward trend. And obviously, we're talking about a 20-25 kilowatt capacity we cannot consume. We have a 5 kilowatt capacity that we can consume, and obviously, Europe generally follows America, and in terms of regulations in the coming periods, we believe that Europe will be one of the potential markets, and if they close their doors to Europe, then with our location advantage and with our know-how that we will obtain in this process, maybe as cells, or, I mean, there are not so many manufacturers at the moment, but if these regulations become stricter towards China, then maybe certain companies will open factories in Europe as well. We will be able to provide cells or completed panel to these countries. I don't believe that any of these 5-6 logistics companies have only made these investments considering a local market alone. I mean, Italy's already started this. They want non-Chinese content products. Banks can insist on these as well. If other countries follow suit, then this will mean a very significant potential market for manufacturers, and Europe will make this more sustainable in the long run for our manufacturers in Turkey. Thank you, Emre Bey. If we have any time remaining, I would like to touch upon this again, but to efficiently use our time, I'm going to continue with Burak Bey. Burak Bey, Business Development Director for Vatox, and we now have a local inverter. This, for us and for investors, is critical because the more local production, the more local contribution we have, how much impact does it have, how much of a positive impact it has on our investments. First of all, I want to listen to your experiences, your market share, your increasing market share, and the values. I'd like you to share this with us. Yes, of course. First of all, welcome to you all. Today, obviously, in Turkey, we have the local and national product move actions by the states, and Emre Bey touched upon these as well, both on the panel side and on the inverter side, and in general, let's not just call this inverter, but on power electronics, because on the PCS side, the battery inverter side, there are also some contributions and support incentives that are going to be provided. And at the same time, almost all components that helps consist for the power plants, power generation, the national and local movements have started in this regard. We began clearly the manufacturing of local inverters, and we have 350, 400 megawatts in the field, local inverters that are currently in action, and together with a Far East technology company, I mean, I can mention their name because they're here with us as well. We're carrying this out with Huawei. Huawei is our technology provider here, and we established this factory together with Huawei. The main know-how, obviously, of the technology is being provided by Huawei, and specifically the latest local components regulation, and together with other regulations that have been issued, we've taken precautions for this previously. The software and algorithmic software is also becoming local as well. Huawei in Turkey also has established or is establishing a wide R&D and development team, and a very high investment is being carried out here. And in the coming processes, the inverters that we are producing and the PCSs that we are producing, manufacturing, their software will also become local. And for this, on the inverter side, this will increase our local ratio to approximately 65%. And on the inverter side, there are some specific contributions. If we consider that on 100 score, or on a score of 100, 65 is from a local cell panel, 25 points are from a local inverter. And when we look at the local contribution per megawatt hour, we're looking at $15 in storage power stations contribution we can see. And the inverter side, the contribution is approximately $3.75. And just as a very rough calculation, a solar power plant, if we consider it has a 1,700 megawatt hour production, that is 6,400 a year, 5 years. So it's a contribution of over $30,000. This is only from this is just the electricity provided by the solar power plant, and also from the storage side, there is also a contribution here, which is over 5 years, a total of over $40,000, which has a significant impact on the ROI of the investments. we haven't stuck with just local inverters. With Innovators and Vatox, we are also producing PCS and battery inverters. We've started their design at the moment, and the factory for this we hope to put into action in June. And in August, our first local PCS products will be supplied to projects, and local PCS storage project contributions also exist, and these will bring great advantages to investors. And obviously, we're not just talking about large utility scale battery or solar battery projects. Last year, there was a regulation on prior established solar power plants, especially rooftop, where production and consumption is at the same point. This will become very, very important. Alper Sambe will give us more detailed information about this. Our aim here, our objective here is, it was very important to generate energy to date. Energy was very expensive. However, after these regulations, now the grid is more expensive. Using the grid is very expensive because together with hourly offsetting, energy has become more expensive and distribution has become more expensive. So using the grid is now becoming more and more expensive. And what is very important here is that when the grid becomes expensive to use, then storage systems become even more important, even more significant, not just for the system, but managing the system also becomes important. And we're going to have a solution here as well. Innovitas, for years now, in the engineering, in regard for the engineering, one of the main areas that it focuses on, SCADA, PowerPoint controllers, the EMS side, the energy management side. This is also very important, and investors, I believe, need to pay great attention to these investments in software. In the coming days, I believe that being integrated to the grid and utilizing the grid is going to become more expensive and more important. And together with our team, we are continuing our efforts in this regard, especially on the system and software side. Being local and national is our focus, and our efforts are continuing accordingly.
I have two questions. It occurred to me while we were talking. You mentioned the software. Yeah, of course, the hardware has been discussed widely, but software is an important component of this. In the European countries, with the battery installations at the EMS side, against the certain Far Eastern manufacturers, there are different measures in place, and I believe Innovators also have similar studies, and they are used in their international efforts. It would be more reasonable to talk about it when we look at the inverters from the investor side. The most critical component is monitoring system. From the international manufacturers, when we use their inverters, they have their own software, and the generation and the electricity generated on inverter basis, we can monitor it from those systems. In addition to the EMX for inverter only, with the Novatox, do you continue with the Huawei infrastructure, or do you have your own interface, or do you develop your own software? Yeah, here at this point, the Huawei inverter has been in Turkey for many years, and we have the lion's share in the market as a brand. So the investors have an interface that they are familiar with. As innovators, we have a different interface which is similar to our system. But as you said, it's important. The monitoring system and software to be made in Turkey is important because the commerce war is critical in global scale with the restrictions by the US and the European adaptation of such restrictions are critical, and the Chinese manufacturers are encountering certain resistances, which can also occur in the future too. So I cannot name any names, but there are commercial wars that are going on. As the Eastern manufacturers designated Turkey as a hub in this regard. All the products that are manufactured here can be easily exported to Europe for both the panel side and the inverter side. So the technology providers from the Far East, and the consideration of Turkey as a hub is important. And our engineering, especially in the energy sector market, and its development rate in the recent years, and its fast development, opened the doors for us. So we have an advantageous place. Of course, Turkey's engineering and infrastructure and our indigenous products can to be advanced, and we believe it will happen. But the foreign markets and the Western markets will support it, and toward that side, the know-how, immigration and technology transfer will be created. In the Europe, Innovators has big references in Europe with the 200 megawatt hours energy management system that we contract that we signed. We have another reference included in our repertoire. We have references in Baltic countries, so we have a good place in the European markets. Thank you very much. I have questions. I have further questions to you. If you will have more time, I'll turn to you. When we talk about the different product ranges, we have two speakers in the different products. Large manufacturers, the global manufacturers, representatives of the global brands. After Burak, I'd like to give the stage to Ekrem. In the Huawei has been active in Turkey in different branches, different fields. And now we are talking about the HT in the panel side while domesticating the panels, and they converted to the domestic manufacturers. Huawei is strong in the inverter side. In the China, there was a launching event, and we know that with the inverter journey of the Huawei perhaps will continue with the batteries. As a company that works in the different fields, Ekrem, could you talk about the up-to-date technologies and our place in the international competition? And we are talking about offsetting, for early offsetting, the scalability of the products, and more practically speaking, what are included in the product range. I believe you have a presentation which we will project. Can I use it here? I know this is a deviation, but I would like to convey my thoughts with a presentation and explain myself. Thank you very much. Right off the bat, let me underline, in order to achieve its third place in the sector, the ecosystem is important. The energy storage associations, there are a lot of institutions, and their efforts so far have been successful, and we will continue to support their success, both on the regulation side and on sector dynamics. In Turkey, there are a lot of areas to be developed, but we achieve certain levels, and when we look at from the global perspective, in Turkey's development and sectoral development, what contributions can we offer, not as the seller of a technology, but also as a company that's residing in Turkey for the 24 years, how we can improve our contributions in the sector, in the ecosystems. This is the question, this is the main question for us. So let me continue from here. Huawei, as many of you may know, at the global scale, with over 200,000 employees, with 53% of R&D staff members, and active in over 170 countries in many areas in the ICP technology. We provide services to half of the globe, and our indigenous employee rate in Turkey, it's changing of course, but it's approximately close to the 65%. Approximately 2,000 employees are located in Turkey, and we have a domestic employee penetration close to the 65%. For the year 2025, our turnover was close to the 125 billion. In Turkey, since the year 2002, we have been working in different areas, and we recorded certain firsts, especially for indigenous and domestication of the technology. The first nationalization for us was in the ICTN area, in the antenna factory, and then the R&D center, and collaborations with the universities, academia, and localization efforts in the energy field. So currently Huawei is a well-established company with an interest in the development of Turkey. Localization and digitalization and the green energy and the ICT skill. When we look at from those perspectives, we are a technological company, but with the power out of energy, with the digitalization, we have a mission. I'd like to underline an important point. Perhaps everybody remembers the crisis of 2001, 2008, 2013, the pandemics, the crisis in the year 2021. Turkey experienced all of them, and many companies exited Turkey throughout this crisis. These are companies in the energy sector as well as in other sectors. But throughout all this crisis, we maintained a strong position. We are here, we will continue to be here, and in all sectors, we will continue with the dynamic sector structuring. When we look at the scenarios, John mentioned what are the innovations, what are the novelties. Honestly, in the world of ICT, many energy products and the technology, we have been engaged in innovation, and we will continue to engage in the innovation. In the global level, we have inverter transportation close to the 720 gigawatts. We have an energy storage system of 60 gigawatts hours. We have over 140,000 patents. We in the both industries, we provide end-to-end solutions in many fields. In the DV sectors, or EV sector, we've been working in Turkey for over a decade, over 11, perhaps close to 12, 13 gigawatts in Turkey. Yeah, we are the company that received the first admissions. When we talk about the high technology, high-end technology, the PV brand that we have, the Fusion Solar, since the year 2013, 1, 2, 3, the version 1, 2, 3 of the Fusion Solar. Today we have the version 9. As I talk, or no and technological, and you can see in our booth a launching of new and technological products. All of the attendees are invited to visit our booth. With the innovation structure, with the strict immersive technology to the digital technology, and right now, since the year 2023, the grid forming technology that has been continuing, and all of their versions are integrated and implemented with new technological products. For the energy storage systems, we are a vanguard technology, from application to the system, the architecture, the performance, security, the safety, and after-sales services, and the component compliance. This is important. When we talk about end-to-end solutions, this is not just mere rhetoric. At the end of the day, when you talk about end-to-end solution, you need to have a high compatibility of the components to ensure efficiency, prevention of loss and leakages, and operability of the multiple components. This is a position many of our colleagues know about it. In all our product portfolio, end-to-end product is sent as a package. Our strategy has been always the same. With the high usability capacity, scalability, we can talk about innovation in this field too. When we talk about the continuous investment in innovation towards grid technologies, from grid following to the grid supporting to the grid forming, we have a wide range of products. From the grid technologies, we have a professional team. We have a significant professional team. When you talk about grid connectivity technology lab, so it's R&D. There is a significant R&D effort before introducing the products to the market. We have simulation laboratories. When in the field there are live and operational products. We simulate all their results beforehand to provide a proactive service. Today, when we talk about new technologies, especially from 330 kTL, today over 500 kilowatts with the 5 kTLs, we have grid forming inverter is in field now. This is a new IGBT technology with over 25% efficiency, 10% less loss, and when we talk about heat and the volume, we don't need to talk about it. As a communication and technology company, all these technologies, we follow them, and especially the reaction, we take the reactions on system, and we try to keep the minimum, of course. And more than that, the things that will impact the dimension, the weight, and the operation performance, the anti-aliasing fans, from the air cooling to the liquid cooling fan technologies are used in this inverter with less 10% saving in the volume with over 50% power increase from the MPT size. You can see all these in our booths. You're all invited to visit our booth again. I'd like to also underline that when we talk about string and central inverters in the field, in the world of solar power, in the year 2024, in the shipments of the central inverter, there is 7% reduction. So the world is moving into the modular systems, and in the technological side, we talk about edge computing. It is fragmented and modular systems, and architecture is popular now. And what makes you competitive? If you have a good communication sector, you have advantage. So it's goodbye. So it's a goodbye central inverter. Welcome modular structures. With the Fusion Solar 9, it's a redefinition of the ideal SEOE. From the smart power to smart inverter to smart mechanisms and the BBC systems from end to end, not only the inverter but the substation. We are providing all these services, which is a simple and usable and user-friendly system for the users and investors. On the other hand, John asked, what is the offsetting the new regulation? Dear colleagues, in Turkey it's always, in order to better operation of the sector and to achieve desired results, not only the ecosystem itself, but also the investors and not only the vendors and the investors, but also the end users, meaning the domestic users, all the regulations that are overseeing them, how they can better contribute into the ecosystem. So there was a continuing search for that. And third of the government and authorities and the regulation and the legal regulator and the standard determinants, we are in constant contact with them. With the SS, we carried out a lot of activities. Of course, we are not the place that we aimed at, but the logic is simple. At the end of the day, we are trying to achieve a situation where everybody can contribute to the system and the system can contribute to everybody. So this is the responsibility that we try to assume. When we talk about offsetting, there are novelties that come from the use of these new systems. In the past, at the industrial side, when you look at the consumption and production generation and the monthly offsetting, it didn't trigger certain usages of certain products, but with the new regulation, especially in the commercial side, when we look at the energy storage, the industrial energy storage, the demand for it is increasing in this new era. So at this point, the generators and investors, the most healthy products are presentation, and we have the servers, we have PV inverters, we have the KV inverters, we have over 240 kilowatt hours. With the liquid cooling, with the digital algorithm, we have a superior product, which is one-in-one, which means and it's a unique structure, end-to-end with the charging and the energy storage and the PV inverters. Entirety of this ecosystem is provided as a single product. Of course, it is not easy to compare. I don't want to take too much of your time, from design to the purchase, to the installation, to the commissioning. When you compare it at the multiple vendor patchwork, it provides a great facility and optimization, which is unique, and the end-to-end product uses advantages, which reveals all of them. If you have more time, I have a video of 2 minutes, and then I'll end. This, especially at the industrial side, this is the presentation of the products that we use at the industry side, when we talk about the offsetting and the regulations. So this is a provision of the solution and the practice.
Sunduğumuz ürünlerin aslında hangi süreç?
This shows the processes, the laboratory process to the manufacturing tests and the quality test. The use of technology and robotics in our processes and certain. I've seen these facilities, but with the new technologies, we are continuing to serve our clients.
Teşekkür ediyorum.
I'd like to thank you. We have one more slide, which is an end-to-end product, not just product technology side, but for distribution and power generation companies included, from end-to-end digitalization. So that from the digital analysis of power grids, traffic transformer, load capacity, automatic management, preventive maintenance. We have a lot of different digital products, and at the end of the day, what do these serve? They serve a green world. All of us are moving with the aim of a green world, and these are concrete contributions. I'd like to thank all of you, and if I've taken up my time for the next question, then please do forgive me. I'm going to have one last tour of questions in a moment. I would like to thank Ekrem Bey for his contribution. And Alparslan Bey, the floor is going to be yours. But first I want to mention a few things, which is that for a long period now they've been in the Turkish market with their inverters, with their components, with so many equipments. We've talked about inverters, components, and obviously there's also a panel production within the group companies as Astro brand. There is a local production efforts that are ongoing and existing, and then in the coming period for complete manufacturing. And obviously there's also the inverter side. The company is also operating in the inverter sides, and the storage examples of Huawei, there are the first examples of this which we can see in the field. And Shintin, their implementation, I think, was the Aral petrol fields, oil fields. There were microgrid scale implementations there. And I believe we saw so much here. Your experiences here are very important for us because we're not just talking about large-scale implementations. Batteries have so many areas of application. So let's talk a little bit about the existing battery infrastructure and the current launch today, and also in the oil field microgrid implementations applications, what and handicaps you have faced, what point are we on now? Is it a good application, good implementation in the coming periods? Information about production. I just want to give the floor to you to share. Thank you very much. First of all, I'd like to say welcome to all of you. I am the business development manager at Shint, and obviously the company is a little bit older. In 1984 it was established, so it's an approximately 42-year-old company. Started in automotive production, and then it has a structure of a capacity to produce all products, all components in the energy industry. And about 10, 12 years ago, it entered into the Turkish market with components, and storage solutions are brought to Turkey. As our chairperson has mentioned, we've realized many great projects. But also, as all participants have talked about, there is the local, national aspects. There is guidance and a necessity which has been introduced by our states. This is our duty, essentially. Why? Because post-COVID, we had the raw material problems, industry problems that we faced, which have led to meeting our own needs, and in this regard we have a collaboration with Vestel, as our chairperson spoke about. We entered into a collaboration for local production and the energy storage facilities. We will be producing partially here, and we aim to serve directly the Turkish market. And this will offer benefit to investments on several aspects. The initial investments will be lowered. That will be an advantage. And secondly, as it is manufactured here, it will be produced and directly accessible. To date, we were manufacturing in Shanghai and the logistics to Turkey. Now operations will be in Turkey, not only for Turkey, but also to Europe and to other African countries. Will be able to meet demands from this country. If we come to the microgrid, that was necessity is the mother of all invention here. I think that we really reflected that. It was a facility in Urfa. The necessary energy, obviously the diesel generators were established, and with that energy from the diesel generators, electric motors were energized and necessities were met. And on an hourly, this was 750, 800 kilowatt hourly consumption there. And with various diesel generators, this was provided. Obviously, the operating and costs here, I mean, it was high cost for the investor. So we put forward an idea that if we establish this as solar power plant and an energy storage solution, we can have a self-sufficient structure which does not require any external fuel. This was a project that started 2 years ago, and we realized it last year. We established a solar power plant, 1.2 megawatts, and we established the storage facility. And within the day, the power that's generated by the solar power plant met both the system and filled the storage system as well. And after sunset, the storage facility took the entire load and allowed for energy provision uninterrupted throughout the night. And obviously, this brought a great ease to the operator because everything was controlled in their hands digitally. And because there was no fuel diesel consumption, then there was a significant production saving, cost saving there, and this investment became very feasible at the end of the day. And obviously, we have created this for larger projects, larger scales, and so we have prepared proposals, and we're continuing to discuss this with different investors. We have a second project as well, and this is a slightly smaller scale. Microgrid. The name is micro, but it's large itself. It's actually something that keeps the grid operating. This grid forming that Ekrem Bey mentioned is actually foundation here. It establishes the frequency and the production and consumption. So the values from production are transferred to consumption. It was a mining project in Milos. And because it was outside of the city there's a 32-kilometer transmission line that was required, and the construction passing through the forest, the cost, etc., they were a little bit hopeless. And what we said was that, again, above the installation, the solar panels, we integrated it with the industrial facility there, and there was no need for any transmission lines, construction, or investment there. The system has been established, and it's operating very well and meeting all needs of the area. So what I'm trying to say here is that energy storage beyond an arbitrage and offsetting of producing when it is cheap and consuming when it is expensive, it also gives us significant advantages of consuming where it's produced, especially in areas which are far from cities where transmission line investments are very high. So it is very efficient and brings rapidly implementable solutions, and we do have these solutions. So in general, after everyone's speeches here, to be a little bit more interactive, I've got a couple of more questions that have come into my mind, which is a stink inverter, for example. The capacity is slowly increasing, and within this scope, the central inverter, like, for example, interest to central inverters is decreasing. For example, Ekrem Bey mentioned that. When we entered into this market in 2013, 2014, 33 kilowatts, 27 kilowatts inverters was what we started with. With string, we have the 506 inverter, which we're talking about now, was a central inverter back in that day. It was a very significant difference now. So my first question is to Burak Bey. Burak Bey, because you're in collaboration, I'm going to ask you that. The products that you produce right now are 330 kilowatt products, and in the following stage, will this be moving further forwards? And maybe I need to generalize the question a little bit as well. Is there an investment plan in the central inverter side? Is there a scale that will increase in that? What we're trying to do here is that there are certain investments, there are certain investors. So it's a wide basket when we look at the market in Turkey. String inverters, there are investors that prefer this and those which prefer central inverters. And currently, in the fields, we have operating 330 kilowatts Huawei's existing technology inverters, Vatox inverters. And we've started investing in 506 kilowatt inverters, and the investment here will not be as fast as in 330 kilowatts because from our own points, the AC output of 506 is 1,000 watts. Existing inverters 800. So obviously the test devices are not the same test devices. The anti-aging devices that are going to be established are not those that are in existence. So there's a need for additional investment. We've made the decision for this additional investment. So in Q4, the beginning of 2027, 506 kilowatts, again with the same technology and same power, with the Vatox brand, we will be producing this in Turkey. We'll be able to meet this need very easily. Thank you, Murat Bey. And earlier, when we talked about this scale, new lines, new test devices we're talking about here, the same thing is valid for panels as well. Obviously, when we first began, it was 200 watt, 220 watts markets. We're now talking about 620 watt panels. And obviously, technology is changing. Polycrystal, monocrystal, monoperc, half cell. Now, Top Gun technology we're talking about. Or when we look abroad, then obviously there are other various technologies. There are prototype products. There are so many different product ranges. So there's critical investment being carried out here, both by Astro. I'm talking about those present here right now, from Hirte and for Astro, about ingots. There's been a lot of significant investment. So what's the expectation for the next level? Will 620 watts continue, or is it 590? Obviously, the cell dimension and the rectangular cell is transitioned to. So, Emre Bey, what can you tell us? Is there an infrastructure there in place for the next product? With our infrastructure in Turkey entirely, are we able to keep up with newly developing, advancing technology? As you've mentioned, Can Bey, the output of the products at a certain points with the development of technology, they were increasing, but for the past 3-4 years, manufacturers have started playing with the dimensions of the products, and they're continuing to increase output accordingly. In the past 2 years, N-type TOPCon cells are starting to stand out more in the markets. And so I tie to this, that in the beginning of my speech, I talked about the Chinese companies holding 90% of this technology. In the past 3 years, their financial losses, we talked about this in the past 3 years. And I believe that the reason for the deceleration of the change of technologies, I think this has a contribution to it, because companies need to make money to be able to invest in R&D, to establish new factories. When N-type cells emerged, then it was assumed that it would be a 1-year transition technology, and then perocells would be used more. The heterogeneous technology would take over. This was what was foreseen. But what does this mean? This means that your entire existing manufacturing line needs to be put aside, and investment needs to be carried out, and companies do not currently have the financial states to do this. And we think that the N-type will continue to be in the forefront for the coming years. And by just adjusting the dimension between 120 and 640 watts, I think investors will be demanding this, manufacturing will be produced this. And in terms of our own market, the next technology will be silicium and aerosite, and in tandem, and there we do not need to renew the entire production line. The transition can be carried out with less investments, and I believe that efficiency in production will be achieved like this, but I do not believe on the local side or the Chinese side radical developments, neither locally or the China side. I'm going to continue in order right now because we don't have too much time, but maybe 3 minutes each, really quick questions, and maybe obviously we'll have questions from the audience as well. We need to set aside time for this as well. But Alper, I want to ask you, the local production that was launched today, what kind of local production projection is there? And another question I have here is that I'm going to give the floor to Ekrem Bey as well, because the equipment being the same brands and being compliant with each other, we've talked about this. And also, similarly, in Balıkesir, there's an existing power plant integration battery system that has been implemented. I want to talk about that a little bit. But this national, local thing, if you can just summarize in 2 or 3 minutes the component side of this. Being local and national, obviously, is what we launched with Vestel. It's actually the cell packets being local here. In the Izmir Free Zone, there is a great factory that they have established there. Vestel, for 4 or 5 years, have now been producing these battery packaging for bicycles or for other white goods. This has been carried out. There's a huge investment, and they were carrying out the energy storage system packaging as well. This packaging units being produced locally. Obviously, 80% capacity of a container is the battery. When we consider this, when you create the battery, then 80% of the components are actually completed. That's how our collaboration will continue. And obviously, Chintin, we have an end-to-end solution here. We have formed a collaboration on the battery side, but the other components, all of them, obviously, we will be continuing with Chinese technology. The BMS, the air cooling, liquid cooling, the control systems, followed by this, the EMS, the control systems, the auxiliary complementary systems. Obviously, we produce the PCS ourselves. This is our advantage in semiconductor. The skids against will be again a part of our production. Like, for example, this 5 megawatt hour. The battery systems were from China again. We have 2 licensed 10 megawatt hour projects. Again, the batteries, the skids, we provide end-to-end solutions as Chinto. I'm going to give the floor finally to Ekrem Bey, and then if we have any questions, then if we have time, I will ask questions from our audience. We have an implementation application in Balıkesir Energy Sun wind power station. It's quite a complex project. Can you summarize a little bit about that project for us? Yes, of course. I guess you can hear me. Now, this was the first implementation in Turkey. In both Balıkesir and we have a natural gas power station, a hydro, we have hydrogen, we have solar, we have wind, we have all of these, and we integrated energy storage solution there as well. And we have a synergy here that is operating in. We had no problem with the acceptance for the licensing, and as a first application, we carried this out with. We currently have a 2.36 megawatt hour and 5 megawatt hour products as well. It's kind of a hybrid cooling system that we have that's in implementation there. And it's the first accepted standardized system. In Polat and Manisa, again, that is integrated with just wind. We have a 4 megawatt hour first application again that we can list. It operates in great synergy, especially the grid integration. The prioritization of Enerjisa obviously is dependent on our strategy. So the PCS again is Huawei PCS that we've utilized there. And as you have mentioned, the point-to-point solution in every product, in every solution we prefer, in both telecommunications, in energy. We see that end-to-end solutions are a solution to many problems. So you can lower even losses. When you use 2 different brands, then the issues that you face in after-sales or any issues that you face in the equipment, we've experienced this so much. You overcome this with end-to-end solutions. And as you have mentioned, this in terms of the vendor, and it's easy to manage, and also as end consumer, it's easy to manage. So this is based entirely on the technology here. An end-to-end product is not something that's easy to create. Like the inverter is separate, the ESS is separate, everything, all the technologies we utilize are all separate components. The communication systems, the management systems, all of these have to work in harmony and compliance. And I am hearing that both in Turkey and in other countries, in other places, that multi-vendor systems in terms of integration and the compliance of the technologies take a lot of time, acceptance takes a lot of time. Obviously, real investment right now is lower, but when that increases in the future, these problems will increase. Obviously, this can be proved scientifically as well, that this is going to happen. So we need to guide the technology, the end user, the regulation. Everything needs to be guided in harmony and together. In Turkey, how can we make this business, this grid, more efficient? How can we increase this technology from our products and local technologies? And I think many associations need to take this initiative and survive, and I do believe that they've been doing their best to date. Thank you so much. We're running out of time right now, and we've considered so many different aspects here, both in terms of product from panel, battery, and also the local and import transitions we've discussed with our very dear participants and contributors here. I can take one or two very quick questions if we have any questions. Otherwise, I will be thanking you all. Obviously, we've talked about the technology, the components, but also there is the on-site application and the control, the engineering side of things. The control and implementation here, and what falls to consultancy companies here right now. If you explain that, that would be great, because that is a very important subject as well. An energy investment seems simple, like you have the panel, the inverter, you can add this, add that. It seems feasible, doable, but like Ekrem Bey mentioned, these integration issues and the significant issues that you face after the investment lead to problems to the investor. So what kind of structure can be established accordingly? That's a surprise for me as well. So let me answer this question. I can explain it as such that why do we trust our know-how here right now? Because prior to starting to work on the battery projects in Turkey, we had experiences abroad. Obviously, there were differences. Obviously, there are those that are directly integrated to the grid. There are standalone storage systems. There are infrastructure differences, especially in the grid forming side. So we also provided know-how transfer. Our battery know-how was transferred to this. So when we come to this comprehensive system that we talk about with you, for years now, we've been providing audit and control and consultancy services, so we can foresee what we're going to face in this. Obviously, the battery system is coming up from behind, but we're talking about a new hardware for the entire world. And the point we've reached right now, where do we experience this? I can say very clearly that we have to divide the terms and conditions here. Normally, one single battery terms and conditions, the BMS, the EMS, the grid integration, the product selection, the product criteria were able to be utilized from one terms and conditions, but now we have to make it compliant with our own regulations. AC, DC capacity needs to be determined, arbitrage, its peak sharing strategy. We have to determine all of this ourselves. In addition to this, also, obviously, the scale of investment is increasing, the number of components is increasing, costs are increasing, and the investor directly from the vendors, from the product providers or suppliers, obtain different prices, different for the battery, for the PCS, for the EMS, the panel, inverter, transformer. These were already things we were facing for a long time. Obviously, we wish that we could, at one point, just with one terms and conditions be able to progress with this, but unfortunately the expectations of the investors and their demands, we have to adjust accordingly. So we almost have sub-terms and conditions, because we have the terms and conditions, we have the sub-terms of conditions. The integration with other products are referred there. If there's a selected product, then obviously the infrastructure details need to be provided to both the supplier and the contractor. Otherwise, we can face extreme problems. And when it comes to our end audits or in the investor acceptance projects, like, for example, a process that we can complete in 15 days could take a month or more. So the commissioning processes can become a problem for us. Thank you very much. I just want to add something very briefly. You brought the subject to a great point here, but there's another matter here. Obviously, solar power stations obviously had the commissioning, the EPC, etc., of certain components that was possible. But now on the battery side, especially in industry, there's the CNI market that they need to enter quickly in industry. We'll see that in the coming days. On the battery side, the risk, especially the safety security risk, is more critical here. And these are now entering our homes and our factories. When they're now indoor, the risk is now more critical. And as Can has said, the audit control side and the product selection is now critical. Because here we now have both the security, safety of life and products, which is very important, paramount here. So for investors, when making their product selection, we can see that they need to be much more careful because the product is no longer in the field, it's not in the open area, it is now indoors and will continue to be positioned indoors. Thank you very much to all participants, and I thank you all, our audience, for listening. We've come to the end of our period, but if you have any individual questions, we will be around, so please feel free. Thank you very much for listening.
Merhaba.
Hello everyone. Sound check. Is it okay? You can all hear me? Yeah. Welcome you all to Solarex Sun our panel. We have 1 hour. We will try to pay attention to the timing. But as you can all appreciate, when you talk about financing, 1 hour would not suffice to properly talk about everything. But we will try to convey everything about the important aspects. I'd like to open the session very shortly and share my opinions. I'm a former banking officer, and for the last 13-14 years I've been working in the green financing. When you look at in the last 5 years, there is an acceleration in the green transformation. The word transformation is an ambitious word. The color of everything changed, and the color of the money becomes greener. When we talk about the green transformation, the technology and is important parameter. But when you look at their importance, are they enough to ensure the transformation? No, it's not. But because the driver of the actual transformation in the globe is the transformation of the capital. And for the year 2026, 8, 9, perhaps 8, 7, 8, perhaps 9 trillion USD of investment will be allocated to the green transformation. So when you talk about such amounts of money, then you can see that this is the process of revolution of the capital. So are we talking about the romantic transformation process or an actual transformation process of the system? We will try to discuss it. My valuable colleagues are here with us today. The engineering department chair, Dr. Farid Saltuk from Turkey's investment banking, İşlet'in marketing director Altan İlgün, and Erdem Sezer from Turkey Development Bank, the sectoral research department, and Çin Başar Yılmaz. My dear friends and colleagues, we have been with them in many panels for the long years. What we can do regarding the green transformation. So let me start with my first question. I'd like to pose it to the Fatih. I'd like to make a remark while opening the session. When I started the banking, there was a problem of access to the financing. Today we are still talking about it, and I believe the same question applied before when I started banking sector. So my objective today here and with the panelists here, after this session, perhaps our discourse would change about it, because the question of accessing to the financing, as it is considered deemed as a problem, it will continue to remain in your mouths and in your agendas. Because financing is a question of design, and with the appropriate design, you can access the appropriate resources. The figures always tell the truth. Since the year 2013, in Turkey, approximately 120 billion USD has been allocated by the banks and the leasing institutions in Turkey for the green transformation. So access to the financing is actually possible. So who are the architects of this design, and what are the responsibilities of those architects? This will be my first question, and then I will ask another. First of all, thank you very much for your kind invitation, Selen. And I would like to extend my greetings to the attendees. There are discipline structures, project developers, project sponsors, the technical experts, the consultants, the creditors, the financing experts, the legal experts, and the financiers, and all the investors constitute a part of this financial design. I agree with you when you say this is more of a the proper designing question rather than a question of accessing to the financing. As the Development and Investment Bank, we carry out our assessment in collaboration with 4 different disciplines. We have a technical assessment, Erdem's department carries out sectoral research and economical assessment, and our financial unit looks at the cash flows, and our social sustainability and social green department looks at the sustainability aspects of the design. So when you look at it, it's a holistic approach by the World Bank to ensure smooth operation. Because when you look at from the single aspect, there is the possibility to hindrance in the sector is increases. So as a structure, we have a multitude of experts involved in the design. You know, our project developers, more than the financial approach, they have a perspective of engineering. They prepare the feasibility reports with that perspective, and the financing starts at a later stage in the project. Is it a factor that affects that challenges the process? Of course, you need to have the engineering approach. I am the director of the financing. I am the director of the engineering department, so engineering needs to be there. But I always say that the first button of the shirt is the technical assessment. If it is wrong, everything else will. If it is not aligned, it is not correct, everything will be a problematic. But as a technical aspect, you might have a suitable assessment, positive assessment, and the financially speaking, you might have a positive assessment. But when you combine them two, then you have a negative outlook. That's a possibility. By the way of example, the project development sometimes can talk about higher share of the financing or the lower share of the financing. If it's low, then you need the equity needs in the future of the project, and the realization of the project could be challenged afterwards, because during the course it is not easy to make changes. And when you provide a high, extremely high, when you look at the cash flows and the warranty, the leverage structure, perhaps the project can be under an excessive financial burden. So at the very beginning, all the elements needs to be working in harmony to create a single design to provide the best solution. In the first tour, I'd like to talk about the SME financing, and we will promote and what is there in the promotion. And in the second round, we will talk about the financing of the storage. You know, this is the topic for today. When we are talking about the SMEs, their transformation, it is not a question of access to the financing, but it's a question of distributing the financing to the base. It is a question, it's a problem. So what are the approaches in this regard? Because the missions of the development banks for the transformation are important at all scales, at all levels. If you were creating a SME transformation system, what would you change? Do the warranty conditions or the risk sharing or the assessment criteria? What would you change? I can say, as the development and investment bank, our mission and vision is to ensure development of the country and the distribution of the capital to the base. So as a structure, we have a headquarters. We have a small branch in Ankara. We do not have direct access to the COVIs, but through Apex, with the total banking, we can access those clients. What I observe here, and my experiences in the field, show that SMEs, when they apply, or when they want to benefit from a project, their credit risks and other phases. More than that, in the project development phase, the measures to be taken in this phase are more effective. This is our experience. World Bank has solar credits that we allocated them. They can be used by leasings and the other banks. All SMEs and companies can access them. At that point, if the project is developed in a proper way, designed in a proper way, and on the SME side, they sometimes accept it better and process it better. If it's a standardized investment like solar, if it is scalable, we deem it bankable, suitable for financing. And those credits, loans, can provide financing from not only from us but from other banks too. What do we do in this regard? We are working on based on warranties. When the SMEs come, they are not confused because there is a standard. They know what they will do. They know the outcomes. They know the contribution, and it's easier to progress there. Similarly, our intermediary institutions and the banks, our partners, we teach them our own perspective. We provide trainings. In COSGAP, we provided a training for feasibilities. It's important because SMEs are not institutionalized organizations. We do not expect immediate results. But at the end of the day, one is more and bigger than zero. So this is the approach that we provide. When I visit the companies, small companies in the rural areas, their capacities do not have production or sales capacities, and they cannot even calculate their own figures. At that point in the development of the project, what should be calculated in what manner, and what should be assessed in what manner, we are providing a technical consultancy. So this approach will yield better success, my personal opinion, of course. So I will start from that. The project developers are architects of the structures now. Altan, I'd like to pose a question to you. For a while now, we have seen that the banks have been restricting the loan usages, line credits, which increase the volume of the leasings. In this regard, such an opportunity, distributed to the base, how it can be converted into the financing. So, grassroots financing efforts of you, I would like to ask about it. Thank you very much for this opportunity, and I would like to greet all the audience. The timing of the exhibit and the timing of these panels is really good. Coincided an appropriate point. As we all know, there is a war in our region. The Hormuz Strait is closed, and access to the oil is restricted for the countries. This makes all countries to increase their demands in non-fossil oils, non-fossil fuels, and the importance of diversifying your energy resources has become more important. This is an era this is a period of time when we face all these realities. So this is the series of panels coincided in a meaningful period of time. As iş leasing, for the SMEs in their transformation, we have certain policies and tools that we use on our own. And as Fatih just mentioned, the World Bank, IFC, and the ones that we all know, EBRD loans, all these international financing resources like TKD, like TSTB, that can enable transformation for the SMEs and their expertise. We convey them to the SMEs. We have access, they have expertise. So we create a synergy for facilitating the transformation of our SMEs. As iş leasing, sustainability is paramount importance in all our efforts. Since the year 2021, we are in the Sustainability Index of the İstanbul. And we are the only leasing company that's listed in this index. We established a sustainability unit in which 2 environmental engineers are employed. This, from the viewpoint of an engineer, this allows us to serve to the transformation of SMEs from the viewpoint of an engineer. We created certain models with our consultant companies at SME segments and as in the institutional segments, corporate segments. All applications received in our companies is subjected to the ESG rating. This is really meaningful because we are one of the very first that start to implement this, and we implement it throughout our portfolio. It's important in our sector. If you were to invest in $1,000 of machinery or $10 million in machinery, subjected to the different ratings, you are subjected to the assessment. And beyond the classical alignment, allocation of the line credits, in this mode, there is equipment and machinery bought by the client, and there is an ESG. The allocation model had 2 different ratings before, but our new allocation model have a third dimension: governance, environmental, and the financial ratings. So we introduced a new rating, and entirety of our portfolio now is assessed in this manner. As you can see, there is not a single data, but ESG note. The companies with higher ESG rating pay more attention to certain subjects, even if we can, even if there is lack of data there. That's the rating. Okay, Altan, let me ask you about this. Let's say we have a company with a high ESG rating, and if that project is not realized, it would be a shame. But there are question marks regarding their capacity to pay back. So this is a delicate balance there. The success metrics, it is the reduction of the emissions or the financial volume without free of problems. So when you are in such a dilemma, what is the last button that shuts down the entire system? I cannot give you a single answer for this question. There are a lot of metrics, there are a lot of criteria and variables. At such a point, to find the middle way, middle ground, both parties pay maximum attention. Generally, what we see is the companies with higher ESG rating have more positive capacity for payback. So their turnover qualities are better or more corporate institutionalized. Of course, here, having a low rating is not end of the world. The important aspect here is how to improve that, improve on that, how to build on that. So they don't have a static rating. This is the rating and this is the end of the world. It's not an appropriate approach. The important thing is to improve that rating throughout time. If there is a loan relationship has already been established to launch such a process, the important aspect here is that this rating is assessed with our own capacity and with the tech, our partners' expertise are used to record significant important progress. I ask this question because in this processes, the real sectors and the financial sector have prejudices towards each other. The industry says we cannot access the loan, we cannot access the financing. So I want all of us to gain something from each question. In the first question, we underline the fact that the engineering and architecture is important, and here the success rate is not their compatibility with the ESG criteria is important criteria for the assessment period. If you
bulmak adına
Then in order to find that balance there, we need to underline, and we have underlined, that financial institutions have good intents there. On the second tour, I'll be asking a question to you as well. But Bashar, actually, among my guests, we have a guest with both real industry and financial industry experience, and their comments really enrich us. And you're from the finance industry to the real industry, and also you're also an important architect in the architecture side, because financing is not just the use of a loan. There's green bonds, different financing. There's so many different financing models that we're talking about right now. And here, obviously, Chind Green Energy has a strong financial structure behind it, and this power you're sharing with the market, essentially. So my first question to you will be this. Here, you're beyond just being a supplier, a manufacturer, or an implementer. You're also an actor positioned as a financial provider. Can we say that now? Actually, today, energy companies when they include great financial plans and great designs, an architecture and a good model, is that what we can say here? And on this path, obviously, I know all of your work from the market. You have experience in this. So what I'm trying to ask here is that on this journey, how much potential is there? What are the obstacles? What will cause this market to grow, and what will prevent it from growing? Thank you very much. We're having this discussion again in a great moment, and we also had the Solarex 7 years ago that you participated in. We said that I represented a financial institution at that point. We said that the roof market for self-consumption has been opened at that point. We said that, and developing that for the industry was a new line, a new path. It was defining that. In the self-consumption rooftop solar power plant area, we underlined that this was important for the industry. We announced that 7 years ago at Solarex. In the Turkish energy, especially in the renewable energy industry in Turkey, this was an important roadmark. Why? Because it wasn't the change where the public was generating energy, but where consumers would also become power generators. This was a turning point for us. This was important because what financial standing would be here? Would it be like in previous models with the public partnership, or will there be a market price? And then it was specified that it was going to be through offsetting, and with quite satisfactory transformation periods. Many companies whose main area of business is not renewable energy started becoming investors in renewable energy. And at this point, what fell to financial organizations, we had 5, 6 years, 7 years now where they have fulfilled their duties. We're at a new turning point right now. Now, as electrical markets, it can continue as a separate area, but in the field, the investment for self-consumption is a little bit more towards storage, licensed production. Actually, we've entered this period now. And during this period, the prior two periods, so where the private industry was taking the place more of a public, so the beginning of the 2000s, where HES were also included, then unlicensed solar energy power can be our second period. Self-consumption, where investment was a little bit more widespread at the base, where the investor was the consumer and the numbers increased highly. We're now moving into a fourth period, what we can define as a fourth period, which is where projects efficiency analysis will be carried out more, where project design will take a lot more time, which can be considered as a grid infrastructure investments. So we're returning a little bit more to that investment with a new investor typology that are willing to set resources aside for energy. The requirements of this period are going to be very difficult from the prior periods in connection with your question there. So what do I mean by that? Equipment manufacturers will not only be the player that will manufacture and take to the field. Financial institutions, the Turkish financial industry that did its best and achieved great successes in the previous periods will no longer be making decisions on their own. They will request certain guarantees. The analysis, the facility, the management, the performance of the equipment will become more and more important. They were important, they're going to become exponentially more important. And the equipment manufacturers' balance sheet themselves will be important as well in the coming period because the scale has increased, the project's return is not such short-term either. The project return now needs to be managed in energy markets, and the guarantee and the performance of equipment also needs to be continually analyzed. The ESG side of it is at a much higher scale, so the duty that falls upon the product manufacturer, the equipment manufacturer, is achieving the capacity and to be able to offer the products with all components, the guarantee, the performance, and maybe most importantly, as a tool of providing international certification. Because now resources are a lot more difficult to access compared to previous years. And financing is being realized far more differently between the 2019-2020. The terms of payments are a lot more different in self-consumption market as well. The projects we could consider in the 3 to 6 years, so shorter terms essentially. And at the end of the day, we were looking at the investor balance sheets. Obviously, the business efficiency of the projects were considered as well, but we're now back to pure financing, and this time maybe within much more special conditions. And there are so many parts, essentially, that need to work in collaboration, as Solarex mentioned, both within companies and institutions, but also outside of these institutions, based on the guarantee to be provided by the manufacturers, by these companies. We're talking about 10-year loans or credits or longer term that we're going to be dealing with in the coming periods, as much as the financial markets allow. In this coming new periods, we represent this, that both we are on the field as an investor, also as a financer for investors, and acting in harmony with financial institutions. We represent this capacity, and hopefully in the world and in Turkey more often, hopefully soon. And what I can say about the current period is this, and we can go even further in depth in the coming questions. Actually, it's a story. This shows the point we have reached right now. More encompassing and more comprehensive approach is required here. On the one hand, we have the application, the implementer, the manufacturer. They can say, this is my expertise, that's their expertise, I shouldn't enter into this. But such structures are being established right now that in your model, for example, supplier, implementer, financing model brought together. And if we talk about joint financing, this is the structure. And then the remainder for the credit provider institution is a very safe, trustworthy model. It's an important model. And in this regard, I want to recommend that our investors take information and knowledge about this. Now about storage on our agenda. It's an important matter on our agenda, storage. The efforts, the regulations, everything is very dynamic in this regard. We've moved from a static period to a very dynamic period right now in storage. When we consider it in the markets recently, I would consider it as this. Let me start with you, Erdembe. Now, when we consider the market right now, there is investor demand right now. We can see the applications. There's a significant number that has been applied for. There are those with pre-approvals to licensing. I'm not saying there's no demand from from investors. Our financial institutions are quite liquid. We have no financing problems. And on your side, we know the motivation and interest on your side as well. There's no problem there as well. So I'm passing past that as well. Technology is going well. There's no problem there either. Local manufacturers, etc. Which leaves, in my personal opinion, which we all see, is that what asset class the system is going to be positioned in. We have a question mark here. Yes, storage maybe is not a power station, it's not an equipment. But like income optimization or power generation system, we can see like an insurance mechanism for this. It has a completely different position. So starting off from this, and I know that you have assessed a lot of loans, a lot of credits, and I know your motivation there as well. In this regard, what is your approach in financing of storage? Risks are measurable, and action plans can be taken about risks, but uncertainty is more frightening. As someone from the financial industry, it's not very realistic to accept the financial institutions to buy that risk. So when you consider your assessment, is this an income optimization? Is this a production system? How can we measure and position storage? Do we see this as high risk, unmeasurable? So should we have a little bit more cautious? And now we have hourly offsetting. What is your recommendation here? I want to listen to your comprehensive efforts in this regard. Thank you very much, Seyhan Hanım. And again, I want to thank you so much for your invitation. It's great to be here back at Solarex. So we have more than one title, more than one heading in your question. Let's take this one at a time. We all know why there's a need for storage, because when we look at the distribution ecosystem, the transmission ecosystem, there's a high supply, especially in renewable energy. But when we look at demand, we don't see such an increase in demand. And naturally, when we look at the price, the hourly under 100 lira, we see this is increasing. So this shows that we need flexibility. And together with flexibility, we need some regulations. When we look at global examples here, there is a significant renewable energy penetration in certain markets, and we see that storage follows this directly. Because this technology, which has interrupted production, needs to overcome these load needs. This is something we all know and agree upon. So in Turkey, the process has been a little bit different here. If we look at the UK or Germany, the subject evolved a little bit differently. Here we had applications about approximately 200 gigawatts, which is exponentially higher than the installed capacity here. And as we have the pre-license of 300-odd gigawatts here, and as a country, as the energy industry, we're open to innovation, and we love to adapt to these innovations, to new technology. But between adaptation and compliance, there's a very fine line here, a final nuance here. And this nuance is that when a new business idea comes, the compliance with legislation, the effect on cash flow, we need to analyze very well. And when we analyze this, we see that, especially in co-located, so solar, wind, storage facilities, when we look at the final aim there, final objective here, it is lowering the balancing costs. That's what we would expect, because when we look at the lack of balance in wind, especially the cost of this in the last legislation, we're looking to optimize this lack of balance. But I'm going to talk about various cases with no name. But here, the storage cost when we can structure this accordingly, we've talked about arbitrage, we've talked about load transmission, like buying at zero and giving to the grid when it's expensive, etc. Feasibility is not easy here. And in terms of understanding, we need to come to an agreement together with storage investors. Is this an income model? Yes, it's an income model. And there are multiple income models here, but also, in the end, storage needs to be established on minimizing this lack of balance. And the transmission system demands this as well. When we look at the demands of the transmission companies, this lack of balance needs to be managed with minimum effort and minimum cost. So a storage system facility is established and protect me. That is what is basically being said. But the investor needs to understand this as well. And when we consider it in terms of financing, normally we're looking at a 1 megawatt investment reaches 250,000 storage investments. So the return on investment obviously is extended here. And on the storage side, when you cannot place a clear cash flow there, as Bashar Bey mentioned earlier, we have a term that exceeds our current terms. So when doing long-term financing, all banks consider this. Like normally, if there's investment that returns in 6 to 7 years, it's turning into 10 years or more. So what does a bank do? Like a 20-year financing resource, for example, they'll invest 6-7 years in one project and then to another. But when storage has extended return on investments, there's this question mark that arises. So what we need to consider here is the prioritized matter here is the SPV level project, a completely standalone project, or is it a project that has synergy, a wide-scale project? And the synergy is established here when it is an existing company with an existing portfolio, then it is better. Obviously, on the storage side, are there question marks? Yes. Can it be overcome? Yes. Recently, we had a workshop with the World Bank, and we recommended it very clearly that in times when inconsistency is high, in periods when new mechanisms are being introduced with set buying guarantees until the technology matures or until all parties understand this can be overcome. And my recommendation here, which I repeat constantly, is that the capacity mechanism to be placed for various periods. What do I mean by capacity mechanisms? Especially in the transmission system where there are limitations, if a capacity mechanism is defined for this, and a variable price when operating, then at least there will be a more foreseeable cash flow that can be established here. And in the previous days in our workshop, we comprehensively passed this on to TEAS and the EPDK, and there is a positive approach from TEAS in this regard. But there's also the perception that there is auxiliary services as well. But at this period, it may appear easy, but there's a limited capacity here, so it is not easy. So our priority here as financiers is, where possible, to finance bankable projects, but also as a development bank to contribute to the Turkish developments. We want to contribute to legislation developing, and we will continue to contribute accordingly.
I also would like to ask another thing in the field. When I meet with the investors, there is a demand for 100% financing in the investors. Do you want to say anything about it? Is it realistic? Is it a challenging aspect for the process? Is there a message that you would like to convey? Yeah, of course they can demand it, but at the end of the day, there is a rationale to the financing. There is a set of guidelines to be followed. Of course, we would love to provide 100% financing, but when you look at the investors themselves, they need to put an effort which is coming from their equity, their capital. So when you look at the feasibilities without the capital support, the long-term financing of these projects are real difficult, to be honest. And there are instantaneous legislative changes. You mentioned it. The legislative risk of the financial sector, it is not natural for the sector to take the entirety of the risk. Perhaps we did not discuss every side that, but in the non-financed side we financed a lot of self-consumption projects based on the monthly offsetting. Now all of them are turned into the hourly offsetting. So we are receiving questions how we are going to carry out it. We need to be able to manage them. Of course, it is not easy to manage, but we are confident in ourselves. We can do it. When you talk about renewable technologies with novelties in the technologies, the investors themselves need to undertake their own responsibilities. So I'd like to ask you another question. Perhaps then have another tour with the rest of the speakers. In the last decade, in the year 2013, the investment cost of the megawatt was $2 million or so, and over 60% of reduction of the costs has occurred in the last decade. When you look at the system costs, and the costs shifted to the other layers, and the electricity become cheaper. But is it the operational cost of the system increased? What is your opinion about it? This is a good question, and the answer is yes. Why? Because the renewable energies, increase of the share of the renewable energy in a grid has an effect of reducing the costs, but also increases the cost of the operation. So there is a different balance there. When you look at the global scale, the transmission and the distribution infrastructural cost investments always follow the energy capacity increase investments. So you first increase the capacity and then the infrastructure, the investments come. Today you can complete a solar power plant easily, but when you want to build a transformer station with the expropriations, it takes up to 3 years. You sometimes have problems with the contractors too. So it is a time-consuming process. So the energy capacity leads the infrastructure investments, which inevitably lead to the significant costs to the operator, and also wastage of the renewable energy. Recent studies show that over 16% of the renewable energy was wasted with the instruction to shed load. So when you look at Turkey, you know the companies received load shedding instructions, which will also continue to be happening. Which means that since we cannot store the energy, and since we cannot plan the demand, there is a shadow cost in that field too. This is something we always think that the transformer stations create a cost, but there is a total cost of the entirety of the system, and the figure in Turkey is not low actually. So if you were to respond to your question, yes, the infrastructure costs are increased and will continue to increase. And the World Bank now, with the HPC, they plans the place to invest significantly. And secondly, if those investments are not made, we will continue to see wasting the renewable energy that has already been generated. Would you like to add anything from this point? Yes, when we talk about the energy infrastructure, it is important. In the year 2013-14, the solar started, but in the year 2007, there were hydroelectric power plants. When they were built, their operational cost was about €1,000, and then the figure increased to the €100,000 afterwards. So this is a planning question. The government had an objective to increase the share of the renewable energy investments, and the licenses were open to all investors, and then the tenders started, and then bidding started, and then additional system connectivity costs occurred, and yes, the energy infrastructure impacts it. But these are also considerations that have reflections on the system, because the system is a living creature structure. When you invest €1,000, it impacts a larger area, which is then reflected in the operational costs. Thank you very much. Mr. Altan, when we talk about the storage, the expectations of the investors, I am in contact with the investors from different regions of Turkey. My personal experience, I can say that, technically speaking, I admire the determination of the investors in the storage. They are working they are studying their lessons, they are diligent in their equipment and supplier selections. But for financing, their own staff members are not qualified to access the sources and the financing. Accessing the proper resources, and given the fact that the figures are extremely high, they have delicate calculations, and in order to be able to act rapidly, they keep telling me, saying, no, we would like to see financing institutions that can match our pace. Of course, the financing actors have their own expectations too. So, given the fact that there is a increasing movement in the field sector, and how is your approach to the storage as a leasing institution? And now also, leasing is a financing of equipment. It's the essence is the structure of the leasing. But here we are talking about a generation system more than equipment. So how do you measure its risks, and how do you finance it as an asset? I'd like to ask about it. It's a good question. Thank you very much. In our sector, we are yet to start experience it. Before start, we were discussing among ourselves. After a while, the projects will be speeding up, and more projects we will receive. Yeah, this is something that we will live and see. This is the short answer. But given the fact that we are in the third transformation phase of the industry, and given the fact that we have lived through and succeeded in the first 3 phases of transformation, yeah, the leasing sector will continue to produce success in this 4th transformation too. Recently in Spain, they experienced significant power outages. 2 countries experienced over 1 week of total blackouts, almost quasi-total blackout. With the storage, what is the relationship between this and the storage when we look at it? Of course, I'm not the technical expert in this field, and I would like to step above my boundaries. But when we read about it, when we listen to the experts, there are certain elements that are common. One of those elements is in the installed power of this capacity of these 2 countries, the renewable energy is dominantly have higher share. They do not have diversification of the resources. The wind and the solar are the dominant sources. And secondly, they do not have the technical capabilities to store that. Because as we mentioned, if you do not manage the supply with a good engineering, then the power plants are closed, turned off in consequence. And when a power plant is stopped, it is not easy to reactivate it with the same efficiency. So recently 2 countries experienced these problems. Turkey is positioning itself with regards to this technology with the proper legislative changes. Our countries, the installed electricity capacity and the diversification of the infrastructure infrastructure is good. So storage in Turkey has a bright future regarding storage. This is our opinion. Of course, the risk elements for us are, first of all, as we just mentioned, the investment cost is increasing. The operational cost is increasing, secondly. Therefore, the return on investment is longer. So these three elements, negative elements, complement each other. The fourth one, as a country, this is a new technology. So in 2-3 years, how this technology will function, what will be the efficiency rates, we do not have any experience in this regard. Therefore, uncertainties are there in front of us. The positive side, since you can store it, it is more foreseeable, more constant credit line. This is a positive side. This is not only for the solar power. There are various other renewable energy models that are practicable. And climate change is a fact that's there. And your data from the past and the projections for the future do not overlay because the climate changes. You build a power plant and you foresee 50 years of water flow, but the water isn't there anymore. So the storage technically speaking, storage capability is meaningful for both the investor and the creditor. So when we talk about it in turn together, leasing from its instinctive reflex, just like in other sectors, as Bashar mentioned, it is the common project financing where the investor and the generator come together and work hand in hand. They will provide the best opportunities for progress. The structure that built, installed, maintained the system and the institution access to the end user simultaneously will provide a satisfactory result improvement for both three sides. So this is an inclusive perspective and the important design, a closed cycle design for all the stakeholders needs to be there. Of course, the build, operate and transfer and your build and operate model is valuable. When you undertake the financial risks of the business, it's a similar question, but as the equipment provider, implementer, and the financial responsible structure, what is your risk assessment? Of course, you are in the safe zone as the equipment implement party with controlling everything, but sometimes this can be a disadvantage. So what are your responsibilities? If there is an example, I would like to hear it through an example. Of course, the models are there. Can change depending on the needs of the project and the investor. When we start from the most recent example with this solar power plant with the license and storage, we are not on the theoretical side of the aspect. In Konya Kulu district of Konya province, a financial institution is partner in a project in which we provide the equipment supplier and we are providing installation services in another project in the central Anatolia or in financial institutions financed project. We provided a certain part of equity in this project. So along with the financial institution, we created a dynamic with our own equity to implement this project. This is with the build, operate and build, operate, transfer model. This is a rethinking of this model according to the needs. At this point, we can did you seek to do? Yeah, we are carrying our determining. We are undertaking this with our financing institution. There are examples in which we use financing, and there are other examples in which we use our own equity, both for self-consumption and selling. With certain warranties, we can continue. Of course, depending on the approval by the financial institutions. In certain other projects, entirety of the equity capital is given by our side, and at a certain term, this will be paid back. There is a structure like that. In the licensed world with storage, there will be more models in which we will be investors, in which we will be more together with our financing institutions. All the concerns that can be understandable, depending on the negotiation and in a contractual relationship, minimized and risks managed, and for implementation of the for the installation and building of the facility, and for the operations phase 2. Of course, there is a significant capacity, 2,000 megawatts, 3,000 megawatts can be installed. We have the permits for that. With the realization of this, our models will be further evolved. And what I see personally from the demands, as far as I can understand, and new models involving financial institutions will be developed. This will be alleviating us, the financiers, and the suppliers. In our self-consumption build and operate model, we never had any problems in licensed project implementation, because for the self-consumption we have a contractual data and operational relationship that's more clear, and in the future we will add more models for this structure.
So my general understanding here, I don't know whether it's the same with you, it's now risk sharing is very, very important. It's at a very important point, and I just want to end on one sentence and ask for one sentence from each of you, and then if we have any questions, we'll take any questions from the audience. The financing side of it, the finance not being a tool, but now being a design. We can see we want our narrative to evolve in this manner as well. So the actual thing here is that the policies, the technology, the financing, obviously there are other parameters as well, but that is the important part of it. So maybe the problem here is that the lack of compliance maybe between these. Is that the problem? I want one or two sentences of comments from you. Actually, it's that lack of compliance there between the two, because whenever you capture that harmony, then you continue successfully and implement investments successfully. We mentioned the financial design at the beginning of the session as well. When every specialty comes together and designs this together, then achieving success, the ratio of this increases. Yes, of course, it's a lack of harmony, definitely, because if the parties make the efforts to understand each other's language, then those projects, together with models where risks are managed, then with models that manage risks but do not alleviate them entirely, they can be implemented, these projects. We've seen many examples of this. Turkish parties, we can see that projects where the parties have tried to understand each other's language have been successful. What I want to say here is that every feasible project does not have to be bankable, and not every bankable project has to be feasible. And this is actually a back and forth between the financer and the investor, but there are a few points here that I want to touch upon. First of all, the investor, when carrying out the feasibility study, do they really consider the market realities? The second is, have these risks being correctly interpreted and they need to be guaranteed. And on the third, all parties, especially in the coming period, both in terms of legislation and infrastructure, what risks may occur need to be considered and included in risk assessments. You can continue. Your final views, lack of harmony, lack of compliance, etc. I don't want to say anything above our financial institutions, so thank you very much. Do we have any questions from the audience? When there's no question, you always said that we always say that we portrayed the information very well and met expectations. But if there are any questions in your mind, we know the importance of storage. We know the need for financing here. It's a period where everyone is trying to understand everything, and my valuable colleagues have put across how much the financial institutions are valuing this. We hope, obviously, that in the coming years we'll be able to talk about how much we finance certain projects. Hakan Bey, I want to ask you a very brief question, as you have experience in financing. You know about the industry. Do you have any recommendations for storage investors? Is there anything you'd like to say on the financing side or to investors with a couple of sentences? Yes, okay, thank you very much. Our recommendation would be we are also using a lot of efforts to bring storage to Turkey, which we've mentioned in our training, our education programs as well. We mention this very often. Storage is not an energy investment, and we should not be looking at it through the viewpoint of an energy investment, but a different viewpoint. It's something that is required for energy investments. So there needs to be an income plan, there needs to be a return plan, and the parameters need to be fixed where possible, like a keyed-in tariff or PPA. Storage, no matter how integrated it is with energy, no matter how much it is becoming a part of energy, or has become part of energy, we can say, in certain countries, as a cash flow or an investment, it's something completely different. It's a trade, it's a commercial system, it's a buy and sell. And there's no long-term return model, and it can provide significant profits in the long term. It's a very different system, and our investors need to be adapted to this viewpoint, because when an energy investor enters into storage and looks at it like an energy investment, then they can really not know what they're doing in that case, and it can be quite disappointing. Just like when the treasury in a bank is doing buy and sell with projects, long-term financing, they're completely different businesses. Storage is something completely different from energy investments as well. When our investors become aware of this, they will be able to enter into better communication with our financing institutions, and these projects will be implementable much more easily. Thank you very much. To the representative of the Turkish Development Bank, to İş Leasing, and I'd like to thank you all for sparing your time to share your experience with us, and we thank you very much for your attention. Hopefully next year we will be talking about the numbers and the volume of finance projects. Thank you very much.
Yes, I'd like to call myself to the stage. Esteemed guests, dear colleagues, we are together in another Solarex, yet another Solarex. Throughout the exhibition, there are other activities, plenary activities, with speakers. We have speakers from the participants, the opinions and ideas that shed light to the future of the sector, academics and R&D institutions. So everybody who can contribute to the objectives of this exhibit have contributed with their speeches. Let me introduce myself. I am Yüksel Yaşın. I am the General Manager of İstanbul Energy and also I am the Chairman of the Board of Directors of the Electricity Supply Company of the municipality, Metropolitan Municipality of Istanbul. I have a degree in the engineering. I took part in our administrative rules as well as I have academic hat too. I'm giving the graduate lectures in the Aydın University and in the Nişantaşı University. I also give strategic management courses for graduate students. I work in business administration and other aspects. I also suggest this, recommend this to all our colleagues who work in the administrative roles, because the science have been developing non-constantly, and the managers can only develop their businesses as long as they can develop themselves. And we can only contribute to the success to the degree that we keep up with the change and the development. In the Istanbul Energy workers, we have a lot of engineers with the MSCs and MBAs, and we have academic members of staff as well. University and sector collaboration is critical. Here today we are gathered together under the topic of theme of energy. In the opening speech I also mentioned Turkey is yet to achieve independence in the energy. Despite significant efforts in the recent years, we have 50% of dependency to the foreign dependency in the energy. So half of every bit of energy that we consume is brought from abroad. As an energy-rich country, rich in what? Rich in the solar energy efficiency compared to the European geography. Most notably in the Aegean coastal line, we are in one of the top 5 countries in the wind power. We are one of the top 3 countries in the geothermal power. As a resource-rich country, in our 50% dependency to the abroad is a serious concern that we all need to think about. The university is working in the field. We have over 200 universities and the sector, professionals of the sector. All of us need to think about it and put more efforts in bridging that gap. Here today, there are imperialistic powers who come from other continents and to cause chaos in the region. There are powers imperialistic powers who murder innocent children. I'd like to denounce them all from here. But underlining reasons, when we look at them, insufficient energy, insufficient technology, and uncertainties in development and energy. We are a country. I am not going to talk about diplomatic problems of the region and of the world today, but one of the most important critical subjects that needs to be underlined here is achieving the energy independence of the Turkey, and as a country with the capacity to export energy, we still depend on the international markets which we need to question. Every country, every university needs to generate their own energy. Each industrial organization, each enterprise needs to generate their own energy. Each residence needs to think about generating their own energy, both personal and commercial and industrial and local administration and public administration. Organizations need to think about how we can generate our own energy and how fast we can generate it. These exhibitions, these technical meetings are platforms that can trigger such motivation for each other, and they serve as stations. So, if you have 3 to 4 children in your family, one of them needs to engage in the energy, the field of energy. If your nephews and nieces, if you are to recommend a future occupation for them, energy engineering and technological engineering are important. Why? Because there are 3 major crisis focal points in the future. These are water and energy. These critical crisis points are commercial and opportunity. They can create commercial opportunities, but if they are used well, if they cannot be used well, then they turn into real chaos and crisis. The Middle East problem derives from the fact that we cannot use the energy well, even though the Middle Eastern countries are rich in the energy. I wish the Syria, Iraq, or Turkey had enough capacity, had the capacity to generate their own energy in its entirety. Not only the war and the international diplomatic risks, but also the natural risks like the earthquake, as in the example of the earthquake in the Maraş, which destroyed over 10 cities, provinces in Turkey. The same risk applies also for Istanbul and the Marmara region, excessively so. So, everybody living in this region, we all need to think about how we can generate our own energy. For this reason, the solar systems are important. In Istanbul, we do not have the wind energy. We do not have the physical area for that. Perhaps in Çatalca, Silivri, and Şile localities. But to meet the demand of the energy demand of the Istanbul, we do not have the wind reserve. Generation of electricity from tidal waves. Yeah, this is a technical area, but the capacity is not sufficient to meet the demands of the Istanbul and the Marmara. When we look at the roofing in the entirety of the city that we see while we are flying, we need to transform them into the solar panels, because every single surface that rays of the sun touches is a potential source. In the morning session,
if you want to receive the return of your investment in a year, plant a melon. If you want to receive it within 20 years, plant a tree. But if you want to get the return of your investment within 100 years, then cultivate humans, prepare for the future. And one of the importance in strategy in the future is energy. So, instead of investing on bracelets on your wrist, then invest in energy. Consider this. The most important area of investment for Turkey is energy, and at the same time, it is an economic area as well. For this reason, that for capital holders, for investors, instead of investing in construction, in real estate, if they want to invest in areas, in financial areas, then invest in energy. We need to force our hand here. We need to force this. And government policies, the same as they need to activate and strengthen the energy market, the same way that we utilize foreign currency. Energy needs to be utilized. This needs to become a power. So money should not be placed in real estate, in construction. We need to invest in energy here. This is a requirement. In the event of international political crisis, if we cannot provide energy, what will happen? We've seen that in the past 2 weeks. From 54 lira, it's gone up to 84 lira fuel. This increases 30-40%. This isn't just in fuel. This has also triggered inflation. It has triggered oranges, has triggered the kitchen. It has become a crisis of our economy. So we need to invest in renewable energy, not fossil fuels, and everyone, every individual, every NGO, every organization, every structure needs to place this among their priorities. Starting from primary school to middle school to high school, energy clubs need to be established and strengthened. 210 universities, all of them must be generating, must become campuses that generate their own energy, their own electricity. It's easy to talk here from the stage. We're within this, but the teachers talk about this in universities, but there's no solar power system on the roofs of universities. They recommend it. It needs to turn into not do as I say, do as I do. We talk about sustainability, about renewable energies, but if we don't have it in our universities, this is a problem. It cannot be left just at the level of speech. All governments, government buildings, all within 5 years, within all of Turkey, all buildings with suitable roofs need to have solar power. Full stop. Like they captured someone stealing apples in a garden, Fatih's garden. He said, "I wish I became Padişah by the time I threw my hat in the air." And he takes his hat off and he throws it in the air. And he throws his hat in the air and says that all apples in all gardens are foundation goods. I'm saying the same for solar power. Roofs, I'm not talking about agricultural land, I'm talking about covering all tile roofs with solar power. Let's put this to one side. I'm going to try and wrap up as quickly as I can within the hour. I'm going to efficiently use my time. I'm joking there, of course, but we're talking about energy management in local administration. So what is local administration? It is the cities, it's the municipalities, the local administrations, even the muhtars. But their impact, unfortunately, on local administration is very limited. They only have duties regarding a population census. I don't know what other duties they have, but obviously they're needed. When we talk about local administration, energy management, and we're going to be talking about smart cities. So what are smart cities? We've been talking about this a lot. Smart cities, what is their relationship with climate change? We're going to be talking about that. And at the end of this session, I want to have given you basic knowledge of this. From 1880 to 2025, we have a picture of the world. On the left-hand side, we have someone who is healthy. On the right-hand side, we have a smoker who has destroyed their lungs. Consider it like that. Following the Industrial Revolution in 1780, because we have been tied to fossil fuels, the carbon emissions have been increased in the world. Climate crisis has occurred. And in this transformation, we've utilized fossil fuels. We have excess fossil fuel transportation, vehicles, buildings, the energy consumption of buildings, obviously coal power stations, petrol and derivative energy power stations. And as a result, the atmosphere's balance has been completely disrupted, and we are faced with this environment right now. We have managed things badly, and instead of accommodation, we have created buildings. We have cities that no longer have oxygen. And we've done this through engineers and architects. Architects, engineers, and technicians together, we sit together and we talk about now how we're going to fix this. So no matter what we do, this second image will not be possible in any of our lifetimes. Within 30 years, what we have disrupted within 30 or 40 years, what we have disrupted, we do not have a technology will save the world within 150, 200 years. So what can we do? At least this burnt orange we can start correcting a little bit. So at least our grandchildren are not facing with a world where they cannot breathe, where agriculture has ended, where there is no oxygen. We have so much to do so the world does not end up here. What needs to be here? The renewable energy story here. That is where this starts from. Clean energy usage will help us correct this. And here we all have responsibility. Obviously, the world is aware of this as well. International platforms, the United Nations, the European Union, many organizations are taking initiatives, creating initiatives and standards and programs to try and establish this. So this is the history of it. Obviously, there's those prior to this. We have the 1980s, the Norwegian Prime Minister, climate change, and UN subjects that are not even included on the screen. But in 1992, we have the Rio de Janeiro Climate Change Convention, the Kyoto Protocol in 1997. In 2015, we have the Paris Climate Convention. And finally, in 2019, we have the Green Deal and Turkey being included on this. In 2021, when Turkey became a part of this, this became a program, a commitment of the Turkish Republic. And what does this mean? This means that the government and local administrations with NGOs, universities, public institutions, all of them must consider and include a management program, all climate management. They need to create a roadmap. And for this, local administrations have a restructuring strategic, the smart city transition. And when we're talking about smart cities here, we have a definition here, but in all of the services provided by local administration, the utilization of digital technologies, and within this scope, the energy consumed to be based on efficient energy consumption, minimizing emissions together with climate change. So a strategic ecosystem that's ensuring this. And under this wide definition lies this. For something to be smart, it needs to be digitalized. So everything that local administration provides, from transportation to the placement of accommodation of residences, to all systems provided from local administration, needs to be monitorable, manageable, sustainable. And naturally, this has a relationship with energy as well. So the service area which has been established on the shore, the energy needs to be provided by clean energy. By digitalizing this, the systems are smart systems. So if there's a service that's being offered and we can define this digitally, then this is a digitalized smart system. And when we ride municipal buses, we have card systems. The systems where we just swipe and do not even touch, these are smart technological systems. Being able to pay this and for this to be deducted from your credits, these are smart systems. This is an electronic solution that is managed through software. This is what these solutions are. This is in transportation, in taxis, in buildings. It's all the same. So there's an identification, a QR system, for example, in buildings. When this building was built, when the installations were carried out, when it was last revised or strengthened. So with a digitalized system, with a smart management system, this is established, and within this process, the energy we have consumed, being able to provide this with the lowest energy consumption is a part of this ecosystem. And of course, as population increases in cities and as energy consumption increases, this energy production becomes a problem when it comes to the country. And it's for this reason that what our objective is, that every institution, every organization to meet their own energy, for local administrations to make the energy investments to meet their own needs. Dear colleagues, as Istanbul Metropolitan Municipality, including İSKİ, the total consumption, 54% of this is generated by energy resources within its own ecosystem. Some are directly provided, some are provided by providing to the national grid. But the total consumption divided total production is 54%. And what does this mean? This means that the Istanbul Metropolitan Municipality has either invested 54% or it is providing their own 54%. The goal is 100%. If this becomes widespread throughout all of Turkey, if every municipality generated their own energy, this would both mean economic resources, and this is valid for both Urla, for Çırnak as well. In this morning's session, I said the same. Energy is above politics. Governors, municipalities, district municipalities, every city needs to have a model of generating its own power. Managers who cannot even sit at the same table, it is not possible for them to solve this mega system because we are not dependent 5%, 10% to abroad or outside. It is over 50%. 300, 400 apartment complex, if it's going to be approved, for example, then a model needs to be put forward that includes in the policy that it generates its own energy. And the unit that should be working on this is the municipality. So if we do not want to be energy dependent in the future, then in every industrial building that's being constructed, there must be solar power on the roofs. Especially in the Marmara region, this should not be an option. This is a requirement. Because in the event of an Istanbul earthquake, when the national grid is disconnected, industry will come to a halt. Life will come to a halt. Hospitals will come to a halt. This city's energy cannot be met with just generators. It is for this reason that on the macro scale, this, together with state policies, with strong financial models, this needs to be solved. We reiterate this over and over again. The Ziraat Bank, in its establishment, a story of establishments, we need an energy bank to be established, the same way as the agricultural bank was established. In energy investments, energy credit needs to be provided in the same way of providing an invoice support. Yes, let's place panels, but where do we find the money? The same way as we find the financing when we're buying an automobile, when we are establishing a solar power plant, we will find it in the same way with an energy loan. And it is for this reason that in Turkish financing, especially banking, there needs to be solar energy or energy credit incentivized the same way as there for housing credit and vehicle credits. I need to underline this. In smart cities, comprehensive data management, resource efficiency, waste management, sustainable mobility ecosystem, energy optimization and on-site production, environmental monitoring and climate resistance and international reportability. All 7 of these functions are tied to a system which is related to energy infrastructure. There is a need for energy infrastructure for security. The same to protect and utilize our assets. There's a need for the security system. It requires an energy to provide the assets to protect the assets of the municipality as well. So in every mechanic system or physical system that you need to manage requires energy, requires an energy system. It is for this reason that as smart cities with smart techniques, with smart systems, when we consider it as such, energy is a very important, significant part of this system. As Istanbul Metropolitan Municipality Energy Company, what do? We have a biomass energy production, we have renewable energy systems that we are working on, we have sustainable energy and climate action plans that we are working on. I want to touch upon this briefly because we are one of the leading companies in this regard, and to date we have 26 municipalities that we have prepared climate action plans. What does this mean? I wish I had one to hand that I could show you. We have some in our stands that I can show you. So, Mayor, a climate energy roadmap. How much energy consumption do we have? What are our energy investments? What can we do? How can we do it? How can we find or provide financial support together with their action plans? The transition from fossil fuels to renewable energy, clean energy. To be able to be a carbon neutral country by 2050, every municipality needs to become carbon neutral, which means they need to eradicate fossil fuel entirely. And we are carrying out efforts regarding this, and we have completed those for 26 municipalities, and we have approximately 100 municipalities throughout Turkey which have completed this. But I'm sure you will understand there are 1,423 municipalities. We're not even at 10% yet. So we need to act fast. This is a qualification and competency within itself, and unfortunately our local administrations do not know how to manage energy, and they also have difficulties in providing qualified staff in this regard, so we need to accelerate this. I say to my colleagues working in energy, in your areas where you are, please go to your municipalities, ask them for their renewable energy roadmaps. Ask them when they are going to be rid of their fossil fuel transportation vehicles, what transformations are being undertaken. Ask this. All the while we cannot change the vision and viewpoints of local administrations in this regard, we will have difficulties. Fuel management, I want to touch upon a few matters in this regard as well. I'm sure you're aware that electrical vehicles have become more and more widespread. However, Turkey in this regard is unprepared. Being energy dependent is a problem, and the other problem is our energy infrastructure is not sufficient to supply energy for electrical vehicles. In 1980, because of the low transformer capacities and transmission lines, this has meant that it is an obstacle to the widespread use of electrical vehicles, but soon fuel stations, petrol stations will become energy stations. So many companies that are now in the area of petrol stations will become energy. How many fuel stations, petrol stations are there in Turkey, Ömer Bey? How many? In Turkey, how many petrol stations are there, fuel stations are there? 12,500. Please, do take the microphone. Can you hear me? Can you hear me? I can't hear you. Was it 10,500? 12,000. 12,000 petrol stations. Thank you very much, Ömer Bey. Now, when there are so many gas stations, fuel stations, they will over time transition into energy stations. So we need to prepare in this regard. As someone working in the energy industry, if you are going to renew your vehicles, first prioritize hybrid vehicles, because hybrid vehicles consume less fuel, less fossil fuel and derivatives. And for this reason, this has a significant contribution to carbon emissions. At the moment, if we said that everyone needs to change their vehicles to energy vehicles, we do not have the energy infrastructure to meet this, so there needs to be a transitional change here. But hydrogen energy we'll be discussing in the future. When we come to hydrogen energy, that's when we will have the full transformation. That is why hydrogen energy, for me, needs to be one of our focal points. Thank you very much. This is sufficient. This, for example, as I mentioned earlier, this is for the infrastructure of that. This is the Büyükçekmece Municipality Energy Infrastructure Plan roadmap. This is the energy plan. This is a roadmap program that we worked on, and 39 districts in Istanbul, approximately 20 of them have completed these studies. So one mayor leaves or is sent to Silivri. However, sustainable energy plans remain. And obviously, I'm touching upon something there. I'm hoping that in a fair country, in a just country, where we will be able to live in such a country, I wanted to add that as a note. But today, the duty of this stage is a roadmap for renewable energy, and this is how we work on that. So all our mayors and local administrations, they have plans. It's something that's becoming more widespread, but I do have a recommendation for universities, which is that every university must work with one municipality and must include and establish a research institution, and local administrations and universities must work together as stakeholders. And I say the same to participating companies here as well. You must have a technological partnership with every municipality. Local administrations' horizons must be contributed to, and information must be provided to them about the latest technologies in renewable energy. For what reason? Because 4 years ago, a solar panel was 375 watts in production. It is now 640s. So for this reason, latest technology equipment needs to be introduced to local administrations. Yes, İstanbul Energy. Let's just have a little a break here to introduce our company. It's one of our largest energy companies, and I'd like to thank all our stakeholders as well. We have Adnan Bey and Hasan Bey here, colleagues here as well from the lighting. We consider ourselves a part of Istanbul Metropolitan Municipality, but also we are subject to the Turkish commercial law, and we are a legal entity as such. So we do not serve only the local administrations, but also the private industry, private sector. In Istanbul, over 200 industrial buildings we have free of charge surveys how these facilities can carry out their production with the lowest energy consumption, and we provide information accordingly, and we have a certification since 2021. We are also a Fortune 500 company since 2021. And I have colleagues here as well, team members here. I would like a round of applause for them. This was not for us being the first 300. This needs to be a source of motivation to be the top 100. We work on illumination systems from Silivri to Tuzla, approximately with 200 personnel. We work on illumination under the Illumination Directorate with their direction and project support. The old illuminations, conventional lighting systems, are being transformed with renewable energy, and our energy consumption we are monitoring through this. All old lighting components are being replaced with low energy options, and our entire system is under control and under monitoring. 27,000 illumination points we have, 5,500, close to 6,000 of these are being monitored through a SCADA system from a single central point. Again, our lighting and illumination director and colleagues, I would like to thank them for their contributions here as well. I'd like to take this opportunity to thank them. In Silivri Seymen, we have a biomass energy station. We have a model here as well, and I would like to invite all participants to the fair to our stand. At the same time, if there is anyone who would like to view and visit our power station, it's open to all, especially those who are interested in energy. All students, all citizens who are interested in energy, it's open, the doors are open. From a single central point, it's the largest energy station in Turkey. We have solar power and solar energy systems. Again, the Istanbul Metropolitan Municipality, the Parks and Gardens Directorate, we work together. They prepare their projects. We carry out the installation and support, maintenance support. To date, in hundreds of different points, Istanbul Metropolitan Municipalities, buildings and roofs have been installed with solar panel installations, and these efforts are ongoing. energy technologies research we are carrying out together with Yıldız Technical University at their Technopark. We have academic consultants, and all developments and systems that we have developed here, we are carrying that forward to our own products. In Netherlands and Germany, there is the balcony solar system model, which is very widespread in these countries. I think this is very important. At least individually, we can produce our own energy. Obviously, it's going to be utilized off-grid, but for basic consumption, up to 675 watts, this consumption can be met with these panels. This has become quite widespread recently in Germany, and the legal infrastructure also protects this right as well. These mechanical components, while providing health and safety, if they're established in the event of a possible energy disruption in the grid or an earthquake, the minimum needs of a home can be met through these balcony solar systems with the correct storage systems. We do not only produce energy, İstanbul Energy also has 420 personnel in management and close to 50 technical and engineering staff. Also from the Energy Ministry, we have certified consultants. We establish energy management systems, energy identification documents, management systems, energy studies, green building, green certification studies. We carry these out. If you have the need for this, then İstanbul Energy is ready to provide all information to you and to contribute to your service provision as well. But I want to add a brief note here as well. There are other companies in the industry here today as well. We are not a competitor of any company in the industry. We are their stakeholders. We establish infrastructure for them to operate. We are here to provide a public service. İstanbul Energy and Istanbul Metropolitan Municipality Energy Vision shows that within all borders of Istanbul, our dream is for every building to provide its own energy but we are obviously not competing to be able to ensure this, but we will carry out our survey, our study. Let's say this 1 megawatt on top of an industrial facility will give the cost analysis of $200,000, and the owner can obtain their proposals from anyone, and we will not force them into any competition. What makes us satisfied the most is that the business is carried out, not that we are doing it ourselves, because the more buildings within Istanbul borders have solar power systems, that is more of a motivation for us. And at the same time, Istanbul Metropolitan Municipality, within the setup scope, it is one of our goals.
Yes, we mentioned the SECAP. This is Sustainable Energy and Climate Action Plan. It is not only for the local administration, but also we have micro scale of SECAP. This is SECAP for local administration, SECAP for industrial buildings, SECAP for universities and educational institutions. Every school teacher needs to have a green hat. I always tell them, in the green transformation, to achieve the green transformation in the buildings and in the society, you need to start with using a green tie, perhaps. You need to raise awareness in this subject. This is something that we need for the future of this country. And we need to include the energy lectures in the curriculum of the, not only in the universities, but also in the primary schools too. We may not be generating the energy, but every single individual is a consumer of energy. So at the smaller scales, for sustainable energy, the companies need to have their own roadmaps. Perhaps you are members of NGOs and associations. You need to have energy commissions, energy clubs, energy sections. Istanbul Energy is open to provide support to you in this regard. In the Thracian region, all of the provinces in the region are SECAP are prepared for them. We work in the Izmir, in Muğla, and up to Ardahan. In many places of Turkey, we have carried out studies that will lay the groundwork for the energy infrastructure of Turkey. In Hopa, in the next week, we are going to visit Hopa district for the transformation of the clean energy for renewable energy is beneficial for this nation. I'd like to also provide information about the important subject, the Digital Climate Center. You can find information about it on our booth. In May the 4th, we are opening this center. From a single center, we will have the SECAP data of the municipalities in the entirety of the city, entirety of the province. In cooperation with Çorlu district, for instance, we will upload the SECAP data of every single city, every single town that's included in the system. With the investment of the new solar panels, with the increase in the reduction of the carbon emissions, will be added to this database. Say that Tekirdağ has a 1 million emission. Every single solar investment will reduce this to 975,000, 900,000. And until the year 2027, a carbon neutral Tekirdağ will be monitored through this digital climate center. Simultaneously, we will provide online training and support programs to carry out SECAP studies of the municipalities at the far ends of the country. Both at the İstanbul level and Turkey level, a digital climate center is an important program, will be an important program. I mentioned all of this at the beginning, but if we are to bring anything, take anything from this session, we need to have a common terminology. This is the last page. Corporate structuring and strategic management. Many of the participants are senior executives of corporations, like general managers and managers. You may have a different department that's focused on the energy efficiency, and in your strategic business plans, you need to include most energy saving business plans. If we are consuming 100 units of energy, how we can reduce it to 90? How we can reduce it to the 60 by installing solar panels on our roofs? So energy is not a subject that should be addressed by the mechanical engineers or the energy engineers. It needs to be involved in entirety of the organization. Every executive committee needs to have basic information about the energy. This has become popular recently. Many companies, they don't know how to manage their finances. They suffer economically. So we have a new concept called financial literacy. What is it? This is a training program to train the general manager of a company so that he doesn't cause failure of the company with the financial literature. Not only the information about the financial affairs, but also having a literacy about the finances, a prominent concept. Now, the energy literacy is, and I personally believe, energy literacy is a new and important concept. If you are not carrying out energy efficiency programs in your enterprises, you, as a father or a mother, can implement it in your domestic consumption. It is important. When you decide to buy a white good, a consumer goods, if you choose the most energy-saving toaster, for instance, or a fridge with the highest energy efficiency, this is a conceptualization of the energy literacy. This is a perspective that needs to be embraced by all. In all our energy efficiency efforts, in every single building, we achieve at least 20% energy efficiency saving. So 20% is the gain that we achieve. If we pay 1,000 Turkish liras for our electricity bill, we pay at least 200 liras due to our ignorance due to lack of information. So we need to be aware about it. Minimizing the energy consumption also means savings equally in parallel to the consumption. Think about this individually. I'm talking about the individual households. Look at the industry. There are enterprises who pay 50 million Turkish liras per month for their energy consumption. Even 15% would translate into a significant saving in the costs. So our program, our objective is to make sure that the local administrations, the municipalities, the metropolitan municipalities to be able to autonomous in their energy generation. Every single governor needs to have this vision. Every single administration needs to have a vision. The governors of, I am from Gümüşhane province myself. The governor of Gümüşhane needs to think about how we can produce generate entire of the energy that we will consume in this province. And digital, the solar panels that are installed on the, with the digitalization, you have the ability to monitor them from everywhere. If it is broke, if your solar panels are inefficient with flares, or you can manage entirety of your systems. These mobile devices can be used for that. For that reason, the energy, the digital infrastructure, smart mobility and infrastructure, these are all common topics, themes of the age. Blue-green integration and social impact. Yeah, the green building, the buildings that are self-sufficient are important. Individually speaking, every single new building needs to have solar panels. Instead of large air conditioning unit, can have a heat pump. Instead of sending the storm water to the sewage system, you can collect them in somewhere, because there can come a time where you lack water to drink. International financing and cooperations. Turkey is in this regard. I lost the slide. Yeah, there are international financing. There are calls opened for energy efficiencies. You need to pay attention at institutional corporate level. I'd like to reiterate, Turkey has energy resources to achieve self-sufficiency, and we can bridge entirety of our gaps in that regard. But we have different energies. There are incentives for energies, legal administrations, schools, and everyone needs to be incentivized for energy. And in the near future, we need to be self-sufficient in the energy, and we need to get rid of foreign dependency in our energy consumption. And ensuring independence in the energy will also ensure that the country is not a target of the malicious forces. You know, the Middle East is rich, the underground, rich in the underground resources, but surface is demolished by evil forces. Today, all around Turkey, we have the human resources to install solar power plants. We have resources to establish wind power plants and geothermal power plants, but we are slow on that regard. We need to pace up. One day, with the hope of becoming a self-sufficient country one day. Thank you very much for your patience, for your attendance, and your attention. If you have any question, I can answer them. Yes. Unfortunately, can you send the microphone to the gentleman? Thank you very much, sir. It was a lovely speech. Regarding the wind energy, your institution have a lot of work in there, efforts in there. As you mentioned, reducing the dependency to the abroad, and the related risks are significant and critical. In this field, the solar panels, I personally work in a wind turbine manufacturer. Preference of the domestic components for generation. Of course, we shouldn't be discriminating the China and the Far East, but how they will be serviced, or in order to ensure that we do not become a landfill of international wastage, is there any strategic decision making regarding preference of choosing domestic components, especially a large giant of İstanbul Energy in this sector? As Instagram, I see it in Instagram, people say thank you for the discussion. Yes, it is one of the important considerations for us that, as you might know, Turkey in the manufacturing of the solar panel, Turkey ranks top 3 in the Europe level. When we look at the imports, at times we sometimes rank second and first at times. And the manufacturing of the solar panels is one of the strongest muscles of Turkey. But at this point, as a doctorate of the energy, yes to the solar panels on the roofs, it's a must. But if the solar panels to be installed on the ground, not addition systems, but systems that are built on the steel construction structures 2.5 meters above the ground are important, since they will reduce the heating by the solar sun. They can turn the barren lands into the fruitful lands to gain them for the agricultural purposes. For the open fields, a 1 megawatt solar power, when it is installed on the steel construction, it can be generated in 4,000 square meters. So over 70% of efficiency can be achieved for the land usage. And the economic life of the solar panel is only 25 years. When you install the solar panel to the ground, adhere it to the ground, you just cage it to the ground for 25 years. But if you have a gap of 2.5 meters from the ground, clearance of 2.5 meters from the ground for bushes and other small animals. So in the field usages, I believe this type is the only model that's used. This is my personal wish, and as an engineer, the same perspective should be shared by the agriculture engineers too, because many percentage of the land can be used for agricultural purposes if they can be converted into the barren lands can be turned into fruitful lands. So this is my personal perspective. But setting aside my personal ideas, as İstanbul Energy, we operate under the public procurement law, and generally speaking, we create working groups with the domestic producers, manufacturers, and we closely monitor their R&D efforts. Of course, we cannot be doing anything else. Regarding the solar power technology, Turkey is leading in the global competition is something that we desire. Of course, this is Solarex. We are in the Solarex exhibit, but I am a windman. A solar turbine of 5 megawatts. Its capacity factor is almost twice the solar power. So 16 to 18% of the solar, but the wind is around 34%. And at the coastal areas, regions of the Aegean region, it can achieve as much as 48%. Instead of installing 1 megawatt of wind power installed capacity, you need to have 2 megawatts of solar installed capacity. To achieve the same capacity for 5 megawatts of wind power plants, you need to install 10 megawatts of solar installed capacity. You achieve 1 megawatt of solar capacity in 12,000 square meters, but 10 megawatts of wind power can be achieved in 120,000 square meters. Instead of using 20,000 square meters, we can use 5 megawatts of wind. This is the mathematics behind it. So, with the best measurement of the wind efficiency, and I do not fully trust the data from international sources regarding to the wind capacity, because Turkey has a strong position regarding the wind, but instead of instantaneous wind power, they are looking at the annual averages. But wind is an important resource that we need to use, and the wind can be used both daytime and nighttime, while the solar is only for the daytime. And their economic life is 25 years again. So we live in a windy region. But when we started this solar frenzy, we started to ignore the wind. So wind needs to be included in all of it. It requires less surface area. Some environmental activists say that the wind turbines are harming the vegetation and the migratory routes of the birds. There are a lot of studies. Certain buildings can have a height of 20 to 30 meters, but a bird that is killed by wind turbines, which is only 12 meters in height, if a bird is to be impacted by it, it needs to be blind actually. And when you look at the so they do not cause any harm in the migratory activities of the birds and aviation, and they do not cause any the wind turbines do not create any other additional environmental aspects. So let alone thousands of feet in the height, perhaps 100 meters of the migratory routes are not affected by wind turbines. There's a lot of science to be pursued in this regard. So, as one of the most nature-friendly resources it's the wind. This is why I named my nephew Rüzgar, which means wind in Turkish. But wind technology is not developed as rapidly as the solar. We created a wind turbine in Eski, so we can talk with you too. We welcome all wind people. We can also contact other governments. With a lot of provinces in Anatolia have strong wind capacities. So for the energy investments, wind needs to be considered in this regard. This is what I say. Any other question?
Murat Başkanım hoş geldiniz.
Burak Başkan, welcome. Can we just give a microphone as well, please? Dear Chairman, I would like to ask two questions. The first would be the mobility of the future. If you could just hold the microphone a little bit closer. I have two questions for you. The mobility of the future and city infrastructure integration is my first subject. With your Charge Park brand, electrical vehicle charge stations, you're taking significant steps, and I'd like to thank you for your efforts again in this regard. And with the green transformation in the islands, you also have modeled green environments. In the coming decades, where electrical vehicles are going to increase exponentially, do you have the vision? Is Istanbul's infrastructure prepared to support both as a provider of energy do we have infrastructure preparations for these millions of electrical vehicles to operate as virtual power stations? My second question is our existing roads. We have some confusion, obviously, which is owned by the municipality, which by the Ministry of Transportation, but at least those that are under responsibility of the municipality, of Istanbul municipality. here in the side roads aimed at electric energy? Is there any efforts or modeling? Because in many efforts and in many studies regarding solar energy, they have made similar comments, and we have seen foreign examples as well when we travel abroad. Is there a modeling which may be carried out here, even with models? Do we have these models among your projects? Thank you very much. In the first few minutes of the session, I did touch upon this. Unfortunately, Istanbul is clearly a not well-planned city. The busy city centres today, where the green square meter per person and the unit area population planning has not been taken into consideration. Have converted cities not into city plans, but city masses. And now under urban transformation, within a single avenue, in an area of 150, 200 buildings with additional floors, these are being increased to almost twofold. In some places even further, even more. However, the infrastructure of the cities are not ready or not able to meet this increasing demand. And energy is also a roadblock here as well. For this reason, 150, 200 kilowatt DCs are being placed here for short-term charge was a significant problem for us. It is for this reason that we have reached a certain point, but it is now halted. On an avenue having 200 homes, the city infrastructure was created for this, but when this increased to 200, 300, 400 houses, but now the buildings have reached 500, 600, so the existing capacity is not sufficient. So we can only provide 5 kilowatts low capacity charge, all-night chargers, like in Spain, in Barcelona, for example. The small charge kits are only able to meet these needs, but obviously this is not within the purview of the metropolitan municipality. It is the responsibility of AEDAŞ and BEDAŞ, the electrical distribution companies appointed by the ministry, and it's a subject that requires great technical infrastructure and financing. In a place like Bakırköy, where electrical vehicles are increasing exponentially, the system cannot meet the needs. The municipality, for example, has a physical area where they can provide charge for 15 vehicles, but there's no energy infrastructure there. For this reason, especially in apartment complexes, in buildings with large physical areas, there must be solar energy systems so that individual charge systems can be established. With a government-supported investment program, if there is no energy infrastructure with this, with electrical vehicles, the goal of electrical vehicles becoming more widespread will not be able to survive this. It is for this reason that something at the government level is required on this. Otherwise, the Istanbul Metropolitan Municipality has charge station plans for all İspark, but there is no energy infrastructure there. In Kartal, in Maltepe, where's Hasan Bey or Ersin Bey? Ersin Bey, İspark. How many car parks does İspark have? What's the final number? Over 300, I believe. So there are over 300 car parks of İspark. 80% of them do not have the capacity to place 2 DC chargers for electrical vehicles. It is for this reason that the provincial energy needs to be planned, and I see this as a program that needs to be included. Do we have any other further questions? Go ahead. If we could have the microphone as well, please. Celal Yılmaz, Heybeli Maritime Investments Company. First of all, Yüksel Bey, I'd like to thank you for your presentation and your information. Having public administrators to have projects and a viewpoint looking towards the future is very pleasing for us. In a process when the country is passing through such darkness, it is great pleasing. My question is a little bit more about the maritime side of things. For Istanbul municipality, the maritime side of it, we need to query as well. Because we work together, renewable energy systems, especially for the traffic of the Bosphorus, the municipal sea taxis, transportation systems. Is there adaptation being planned, especially from the cleaning of the environment and the long-term environmental impact protection of Istanbul for a positive impact on tourism? The energy resources to be met through the sea, more clean for energy to be generated and utilized on ships and boats, or to be stored and utilized by the boats. Do we have this vision or project within the vision of the metropolitan municipality? Obviously, the maritime transportation of Istanbul has a small maritime vehicles, so sea taxi. 15 of the last 50 are electrical. They're charge systems, but they can carry between 30 to 50 passengers. The ferry boats, the ferries utilized in public transportation, their fuel, unfortunately, is fossil fuel based, and it's for this reason that carbon emissions are very high. Transforming this to electrical in such a physical structure with such strong engines, for such strong motors for these vehicles, the green engine system is unfortunately difficult technologically, but carbon emissions to be decreased here. The green methanol is something we're working on right now. And it's for this reason that emissions are very low in this regard. There needs to be a change in fuel technologies. International organizations, companies, institutions in large maritime transformation. The fossil fuel transformation is very difficult in the coming 2 decades. It is for that reason that in the city of Rüsselsheim we utilize similar motors and engines. If you stop at our stands, I will be able to give you more details there. Like a 5-meter ship motor, for example, they operate at much higher capacity and power. And today's technology utilizes fossil fuels. It is for this reason that carbon emissions are difficult to manage in this regard. But these ferries, because they have large physical environments, we have a solar panel study that we're carrying out in this regard. But this will only cover the internal illuminations lighting, not even 5% of the consumption of the motors or the engines of the ferries. It is difficult to change the capacity. Either green methanol or high technology transformation is required here. On the other hand, electrical, smaller capacity sea taxis becoming more widespread may be another solution. Do we have any other questions? I'd like to thank you all for your patience. If you have any other questions, then we do wait for you at our stands, and we can host you with a tea or coffee. And I just want to give one last note. We talked about the energy bank. We need energy technologies engineering. We need vocational schools. We need higher qualified human resources to be cultivated, and for this, a transformation in education is required. If we want to eat meat, then you need to put meat in the pot. We cannot put spinach in the pot and expect to eat meat. So no matter what we are aiming for and dreaming of, we need to strengthen the infrastructure for this. As in other technological areas, Turkey, please, in energy, please, let's not be those that are following technology but driving technology as Turkey. And for this reason, instead of having such a high number of universities, having specialized universities in technology, in agriculture, and energy technology, having these specialized universities is very important. And having specialized, for example, wind energy, solar energy engineers we need to cultivate. Energy systems engineering is like internal physicians. You don't go to them when you have a cardiac problem. You don't go to them when you have a stomach problem, a gastric problem. It needs to be specialized. And for this reason, in energy engineering today, and energy systems energy specialists cannot be given the responsibility for wind energy if they are specialized in solar energy. You cannot give them a qualification or authority in geothermal either. It is for this reason why energy technologies develop. Specialized energy specialization is a must-have for universities. Thank you.